Alright guys, and going to yesterday's winner, which is the stealth geometric furniture, it's going to be something in this product line. So basically I take an existing piece of recognizable furniture and I stealth it out. What that means is I give it that geometric look that you see on stealth jets and just give it that geometric appeal, and like I did with the French side table over here. However, this is what I'm going to do next. This is a TV table. Let me open it up. This here is a TV table. You usually just eat a meal on the couch in front of your TV with this sort of table. But I'm going to make it stealthed out and maybe add some cool features on there. I was thinking to add a little drawer, possibly a place to put your iPad and phone, and maybe even a laptop stopper up front. So let's say you want to use it for your laptop, you can, but then again, it may not tilt. It will just stay flat like this. But nonetheless, this is the new stealth piece of furniture that I'm going to be working on. Now here's the challenge with this is we got about a 256 cubed build plate. So 256, 256, and 256. And that's not very large, as you saw with the stealth side table. So I'm going to do my very best to make a pieced stealth TV table. And we're going to have to piece it together, maybe do some welding. It's going to be done in PETG, so it'll be pretty sturdy. My only concern is these legs. I hope I can make sturdy legs for this new stealth TV table that are strong enough and that have been pieced together. But I'm pretty sure we can work something out. We'll give it a try. And it's exciting. What we'll do is we'll start out with some couple of sketches, and then once we got the sketches done, I'll take it into Maya and model it, and then we'll slice it, 3D print it, and it'll probably go through a prototyping phase because nothing is ever done perfectly the first time around, or if it is, it's not as common and there's always ways to improve it. But nonetheless, that's what we're going to be making for our next stealth geometric piece of furniture. Hey, what's up everybody? 3D Theory here. It's August 2nd, 2024 at 3:39 p.m. and we're going to work on sketching out our idea for the stealth geometric TV tray. So as you know, we already have our base idea, which was that black table I showed you, and I'll put it up on the screen here. What I'm going to start out with is just writing out a few ideas. So I wrote something out over here, and it says 256 millimeters cubed. This tells me how big the build plate for the A1 is. I'm going to go ahead and first take some measurements actually of the table, and it's right here to my right. So I got my digital ruler here, or tape measure, and I'm going to measure out the length of the legs. Inner legs, 695 millimeters. All right, so the inner legs and the outer legs are the same. So the thickness of these legs equals 22 by 20 millimeters. So there's a crossbar at the bottom, which equals 292 millimeters, as well as right under the table there's two pieces of wood holding a metal bar that both equal 125 millimeters each. So I'll just call it metal bar wood. That's 125 millimeters. We can say there's two of those. And then same for the legs. There's a little wooden bar. There's a little wooden bar that holds the legs as well. So that's 251 millimeters in length. 251 millimeters, and there's two of those. So we'll call this legs bar under table. Okay, and these are all just personal little notes that I'm taking. And we have a cylindrical piece of wood going across as well, and that should be the same as the crossbar down at the bottom, so I'm going to call it cylindrical wood, and we're going to call that 292 millimeters. So first things first is I'm going to go ahead and draw this table out, and then we can kind of add some cool features to it. Hopefully you guys can see what I'm drawing here. Let me actually zoom in. Alright, so just like that, we have the tabletop, and there is this piece of wood on the bottom here that I was talking about with a little screw there. And likewise, there's a piece of wood here in the center, which has this little metal bar down at the bottom, but we're not going to be drawing that just yet. And so we have one set of legs coming out this way, and we have another set of legs coming out this way. All right, so to kind of round those out a bit, let me go ahead and give it some refined lines. All right, so we're just gonna add some lines here, fill out that table leg. All right, just so we can differentiate which one's in the front and which one's in the back. Actually, this should be like this. Wow, this one is deleted. I'm so used to using a computer, I say deleted. All right, guys, and so we have another bar that goes here. Like that. And what I'm drawing looks a little wider, but we're just kind of trying to get the idea over here. It doesn't have to be exactly perfect. So we have a little bar there, which is the same as this one. And then there is this metal bar that goes across here to keep the cylindrical bar that's over here from going out of whack, and as you close it, kind of going astray as you close it. So now that we have this drawn out, we can kind of isolate some pieces and design them out. And so what I'm going to do here is I'm going to designate some pieces here. So what I'm doing here is just kind of like my personal workflow. I like to just isolate all the parts and design them and then put them back together. So we got this part finished. We kind of have an idea of what we're working with. I want to create some features. Some features that are not on here, that are not on this product, and that I want to add as part of the new design. All right, guys, just so you have a refresher, this is where we left off. And here is the TV tray that we're going to be stealthing out, giving it a stealth design. So with all that being said, let's get to designing. All right, guys, so I'm trying to get a better camera angle here than the last video, and hopefully this is a better one. I'm gonna go ahead and sharpen my pencils I'm gonna be using. I got these Staedtler's, what do they call this? Mars Technico. They're made in Germany, but they're drafting pens. And I really like these. You can get them at whatever softness you want, the pencil. And I'm just going to go ahead and sharpen this one actually because it needs a little bit of sharpening. So the cap here has a little sharpening tool, which is neat. So yeah, there's that. Sharpens it. I just kind of flick the pen shavings out of there. But I like to use two different kinds of lead. I call it lead, but it's graphite. And if I can remember correctly, this might be a 8B. It's faintly written on there. Ah, okay. It's a 4B. So you get a little bit of softness, a little bit of a deeper tone with that. I just like to have the variety available. And for this one, I think this is just a, 2H. So hard. Level 2. B stands for soft. I don't know why, but it does. And the difference is that this one you'll see has a very light tone, while this one can become much darker if you press down on it. So that's kind of the power of having two different kinds of pencils, one for lighter tones, one for darker tones. All right, so let's continue with the features. I know that I do want to have a place for, number one, your phone / tablet, like an iPhone or an iPad. So I'm going to call that slot. And I want to have some sort of storage. I don't know if I'll be able to fit any storage on here, but I'm going to do my best to try to incorporate it. And I don't know if I'm going to be able to fit all of these features in there, but I'm going to really do my best to incorporate it in there, just to make it a really cool table, you know. So I also want to maybe have a headphone hook, which would be really cool. Again, don't know. And a cup holder. Is that too ambitious? This is too ambitious, but these are going to be kind of a challenge for me. This one is maybe like an okay, this one here, but this one I feel like I can definitely do. This is pretty simple and straightforward. All right, so those are the 4 features I want to add to the Stealth TV tray. Why I do this is because I want to have an idea in my head of what I'm working with. And so drawing it out is kind of like a way for me to reorganize it, kind of take it apart in my mind and put it back together. And so I know what the parts are. I do realize that I forgot to draw out one piece here from my previous drawing, which is just this piece over on this side. So I'll just draw that out like that. That's kind of a representation of that piece. But really, that's all there is. So we got two medium-sized under table bars, which are these here. And for clarity, I'm actually going to label these with A, B, C, D, E, F. Okay? So these here are A, the small under table bars, which is this. B, metal holder wire, which is this thing here. C, cylindrical wood is this thing here. D, 4 legs, obviously, 1, 2, 3, and 4 is this here. E, and bottom support bar is F. Okay? So we have only so many parts. We have 6 parts, really, and some of them are duplicates of each other. So, with that being said, let's start isolating and designing. So, let's start out with the tabletop. I know that it's kind of a rectangular shape, and it's going to be more so now that we're printing it out on the Bambu Lab A1, because this is intended to be printed on the Bambu Lab A1. It's got a little bit of a chamfer here, a curve, so I want to include that in there. And I'm just drawing it as is, so then we can go ahead and start making our tweaks. Now, I was thinking of creating some sort of hexagonal shape. So we have a hexagon. I quite like that hexagonal shape. So if we were to cut it in half and bring it out that way, we would have something like maybe like that. So we're looking at a shape that looks like that. But so let's go ahead and kind of fill that out and see what we think. That looks kind of cool. I can work with that. But I do feel like I want to make these a little smaller, so we maintain a lot of that surface area. So I'm going to go ahead and draw out that cube again, or that rectangle again rather. And let's make it a lot smaller now. All right. Now that we got that kind of sketched in, let's go ahead and give it some life here. I like the way that's looking. So with that being said, I think we can go ahead and move forward with this. But there is one thing I want to add. I want to add just a simple slot for your iPad or your phone. And it's not going to be fancy in any way. It's just going to be flush so that, let's say you have a plate on there, it's not tilting because of this. So you have a little slot there for your media just in case you want to watch something. So I think we got something cool going on over here. So I like this idea. Now let's see the side of it. How should we design the side of it here? Okay. Now we want to have that hexagonal shape going. Okay, so we have that hexagonal shape like that. And if I were to zoom in to this edge here, let's zoom into that. What would we be seeing? We'd be seeing something like that. Okay? And so, do I want this to just be flat, or do I want some sort of design element there? I think I would appreciate having something that kind of sticks out like this, so that there is a line here that kind of gives it this cool tapered look. And I think that would actually be really nice. Okay, with that being said, let's go ahead and finalize this design. Gonna go ahead and create it in a 2-point perspective here. Create that base there. Then I want to make sure to create that hexagonal shape that I chose. Okay, and then since we don't need that that outline there on the edges, I'm going to go ahead and erase that. And let's go ahead and create this shape we're going for. Okay, all right, and I'm going to add that taper here now. I'm going to add that center line first so I know where to incorporate it. There you have it. So let's kind of bring this to life here. Sometimes designing can be a real tranquil process. Okay. All right, so we have the tabletop almost ready here. I'm just going to add that slot for the iPad and iPhone, or just phones and tablets rather. All right, I think that would actually look like a really cool tabletop for the TV tray. And I'm going to go ahead and separate this area. All right, so I separated this area off, and I'm actually going to label it what it was. So this was, oh, how funny. I didn't include it in the breakdown here. So we're going to call this G and tabletop. Okay, so we have 7 pieces. So we're just going to call this G tabletop. So that's designed out and ready to go. Here is the final version there. All right, so now we have these parts here, which are the medium under table bars. So let's go ahead and start thinking of ways to design that. All right, so for the medium under table bars, it's literally just a rectangular cube. So let's go ahead and draw out the original here. So I think it's going to be a little bit longer than that. Yep. Okay. And it's a little bit chamfered on the edges. Not a little bit, it's actually pretty rounded. So I'm going to take that as a design cue and incorporate that. So we have this kind of cube shape, and since it is kind of rounded like that, it has a pretty big bevel on it, and then therefore a chamfer, because usually bevels start out like that, and then they kind of round it out so that it has a nice soft look. But nonetheless, it's a rounded rectangle like that. So because the shape we're looking at again is kind of like a hexagonal shape, because the edges are chamfered, or rather beveled like this, and then it gets rounded out into a chamfer, we're actually going to work with the more geometric look, which is this look here. So again, we're just going to create the initial box shape. Okay, we're going to create that hexagonal look that it has, but before it moves on to a chamfer, and my point's getting a little dull, so I'm going to sharpen it a little bit. Now we're going to add this in there, kind of finalize the line quality. Bring that over, bring this over. So making a stealth look is pretty much turning out to be using hexagonal shapes for this design. And that's pretty much what the medium under table bars are going to look like. There is one screw here, so I just wanted to make note of that. And I am going to use machine screws for this project. So I was going to make everything 3D printed, but you know what? Let's do make everything 3D printed. Maybe that'll be a good idea, because then you don't have to worry about getting outside parts. You can just 3D print everything. So we can add assembly screws to the mix. So now that we have these sidebars drawn out, let's go ahead. You know what? I'm gonna come up with another design. I just remembered that I want to create some sort of different look for this. So I want to explore one other option first. So I'm going to go ahead and create another rectangular cube here. Okay, and it's probably a little longer than that, so I'm just going to elongate that just a little bit. Okay, and I was thinking of something along the lines of, let me just roughly sketch this out, a half hexagonal shape. So if we have a hexagonal shape that looks like this, I want to take half of it and rotate it, and then I want to create an inner shape and pull it out a little bit so that this is lifted. I think that's actually a really cool look. So I'm going to actually throw in a little bit of a design here. So with that being said, let's create that hexagonal shape here, or half hexagonal shape. If that's going across like that, okay? And I do want it to come out a bit. I think that'll just be a really cool look like that. So let me go ahead and darken these lines, because I just feel like this is too simple. If everything's hexagonal, there really is no variation, and I feel like it can get boring like that. So maybe we can play with the hexagonal shape a little bit. Since the main design element is a hexagonal shape, we can kind of play with that design element. Now, I think that would look cool. So I'm going to go with that design. I like that a lot better than just a simple one here. So let's add that in. All right, I'm going to segment this off. And as a matter of fact, since this bar and this bar are pretty similar, I think I'm going to make B the same design, just shorter. And obviously this one's going to have a screw hole So we're going to call this A and B, called small under table bars. So we got three of the parts here designed out, which is G, A, and B. So we can call that done, we can call that done, and we can call that done. And since we are working with a cylindrical piece of wood, I feel like this would be perfect for that. So without the screw hole, we can use this hexagonal shape as the cylindrical piece of wood. And I'm kind of reappropriating here, or repurposing rather, this piece, because I feel like you can only design a cylindrical piece in so many ways when it's being stealthed out. And we're going to apply that for D, the cylindrical wood. Okay, now with that being said, we have the legs, the bottom support bar, which is this one here, and the assembly screws. So let's go ahead with the bottom support bar. So we have the bottom support bar here, and let's see if we can just think of something that we can do with that very long, elongated square, or rectangle rather, because that's all it is, or it's just a elongated cube, a rectangle if you will. And since our design element is a hexagon, what can we do with this hexagon to make it more interesting? I think once again we could probably just do this sort of shape, or maybe even just do a simpler shape where it's like a triangle. Let's see if we can get kind of like a diamond look going on over here. That's a nice look. Yeah, I think I like that idea. And by the way, if any of you guys were wondering, the way you find the center is you draw an X from one corner diagonally to the other, and likewise to the other. And I'm kind of doing it roughly here, but where that X meets in the middle is where the center of that object is. But this is kind of getting messy, so I'm going to kind of give myself some space to work with. And I'm going to create that diamond shape. I just don't know if I need to go all the way down to the bottom. Yeah, I think I do. Okay. And so this is going to be popping out at this point. It's going to come out a bit, jutting forward like that. And this and these parts would be kind of be pushed back, so it gives that diamond look. And likewise, we can do the same with this. Again, this part would be jutting a little forward while these are going a little backward, and it'll give it this really cool diamond appeal. So let's go ahead and incorporate that into the design. Would I want to do the same for this top piece? I think the top I can leave it, because usually the diamonds are flat up top, and then they have this cool little elongated hexagonal shape. Is it hexagonal? 1, 2, 3, 4, 5, 6, and then a 7th. So that's actually pretty neat. I'm not going to add a diamond shape per se, even though I could if I really wanted to, but I think it'll just kind of look funny. But I think this looks pretty cool. So with that being said, let me kind of darken out these lines. Yeah, there you go. So I'm liking the way this looks. It creates a different kind of look here, but with that stealth look still being incorporated. So we'll keep that bottom bar there, and this will be its design. Okay, so now we have the bottom support bar. Assembly screws, I'll just make something quick. So we have the assembly screws here. And since we got hexagonal shapes going, I'm going to do an inset hexagonal shape. So within whatever it's going into, it's going to be inset. Hence those tolerance tests. It's going to go inside of there, and the cap is going to be flush, but it's just going to be a simple hexagonal screw type of look. But obviously it's going to be 3D printed, so we can kind of just make this whole thing 3D printable, not worry about any sort of outside parts that we have to work with. Okay, so it'll just be something simple like that. Hexagonal screw, just like that there. And we're going to need some washers. So I know that washer would simply just be a hexagonal shape in our design here. There you go. Just something simple. And that's about it for the assembly screws. And we'll just call this washer 2. And give that its check of approval. Alright, so we have a metal holder wire left, as well as the assembly screws are finished. So let me give that a nice check mark. We have the legs and the metal holder wire. And so, as you can see here, we have that metal holder wire. And what that does is that it holds this. Let me zoom out just a tad bit. And what that does is it holds the cylindrical piece from going out of whack as you close the table. And it's pretty thin because it's metal, but we're going to have to make it a little thicker. Alright guys, I realized I drew out this piece without having pressed record. But I went ahead and I drew out, let me see if I can kind of go over it quickly. I went ahead and I drew out a cube, or elongated rectangle here again. And I pretty much just designated the parts I'll need. Just kind of really fast and rough. We're going to need a space for that screw. There you have it. And so that was kind of what I did. I just wanted to do it a lot quicker, just so I can show you what I did. But this is definitely not the one we're going with, so I'm going to X that out. And so we're going to go with this look here. And again, it's going to be wider and thicker so that it has some sort of structural integrity, as opposed to using that cylindrical wire, which is made of metal. We're trying to compensate here with 3D printed parts. And although PETG is strong, especially stronger than PLA, it has a little bit of a flex and still requires some density. Now, we're going to need this part to be pretty straightforward. We can't put too many design elements in there. But on the bottom of this, maybe for the shape here, since it's going to be squared off like that, maybe I can just bring it out just a tad bit like that and have a little flat there. And so we have some sort of design going on the bottom, and I think that'll look really cool. So on the bottom here, like here, there, on the bottom of the bar, we can have that going on. And I think that would look really nice. And to kind of give you a quick illustration of that, I'm going to draw out just this portion here, this portion. And let's say that this comes down like that. And obviously that would go like that, so on and so forth. And so we can kind of have 2 lines here going across to give it that, to add to that geometric look that we're bringing to this table. So there you have it. I think, and then that would also continue on down this way to here, and so on and so forth. So with that being said, we can call this design complete. So that's the metal holder wire, and we're going to be designing the legs now. Okay, so we got the metal holder wire designed out, and finally we've got the legs. So the legs are going to be an interesting design, especially because they're long and they're going to need to bear weight, and that could potentially be a challenge, but we're going to work with it and see what we can come up with. And as you know, the legs are 695 millimeters long, so they're pretty long. They're pretty long legs. So we're going to do the legs now, which is E. I kind of have an idea of what I want to do with the legs. I just don't know if it's going to be able to work because they're going to be at an angle, and I want to make sure that it doesn't wobble or anything of that nature. So the way that the current desk designed their legs, it looks like this. This is a side profile view. So this is how the, let's actually do it in perspective here. So this is how the bottom of the legs are, where it meets the ground. And since it's this shape here, I wanted to do something a little bit fun, but again, I don't know if it's going to work. Let's do a side profile. I wanted to do that hexagonal shape like that, but since the legs are going to be sitting at an angle like this, and maybe I could show you with this one, I feel like it's going to be sitting right on top of that edge. Because I don't want it to be sitting right here, I feel like I got to make another segment there. So let's see what we can work with here. So here's the leg. So we got this, then we have this, then we have it flat, another one, and another one. And it's going to look, because there are more angles here, it's going to look a little bit more rounded, but it's not. It's still going to be segmented like that. It's just going to have more faces in that section to make sure that when it's opened up and being used as a table, it's not going to be sitting on a corner where it doesn't have a lot of surface area to meet with the ground. So with that being said, this is a 1, 2, 3 section. This is a 1, 2, 3, 4, 5 section here. So I think we're going to go with this one here. And then I do want to add this cool pulled out look on the sides. I think that would look really sweet. So let's get the leg drawn out here. Okay. Again, it's more or less like an elongated cube. I always start with the primitive shapes because usually that's what almost everything in this world is made of, or you can kind of reduce it down to. And then it helps you kind of draw out whatever you're wanting to draw out. So as mentioned before, we're going to want to work with 1, 2, 3. Same with here. So we're going to go 1, 2, and 3. 1, 2. And likewise with this one, we're going to have 1, 2, and 3. And 3. So let's come up through here, bring that in. Although that's a more safer design, but I would really like to kind of have this, but really elongated. So maybe something like that. That would be really cool. And maybe I can just add an extra one there so it's not sitting on the edge. And I think that would be a really cool design. And then we can pop this out like that. Yeah, I think that would look really cool. And then obviously this would come out like that. It's kind of rough here, but I feel like that would be a really cool leg design. This one's looking a little too tame for me. This one's looking a little bit more edgy. So I like this one. So we'll quickly draw that one out too. All right. And again, this is going to be coming out like that. So we're going to have a little bit of a edge there. And then we're going to bring those in. And I think that would be a really cool look. Again, it's got to be a little more elongated like that. But since I feel like this is more of a representation of what we're going for, I'm going to mark this as the 1. We'll bring that like that. So we'll call that complete. Hopefully this is enough surface area to meet with the floor. And with the legs, we're going to have to segment them so that where it conjoins, and this is why I did that tolerance test, we're going to have one piece that has this sort of latch, and then we're going to have likewise a piece that has this sort of latch so that we can bring them together. However, I don't want there to be just like this random line here in the center of the legs, or maybe we'll have to do them in 3s, meaning, chop it up into 3 pieces. So what I intend on doing when they connect, there's going to be a little bit of a gap here where I can kind of wrap this ring around so it looks intentional. So in other words, once the pieces are combined, so we can do something like this. So once those pieces are combined, I'm going to now have this little ring that I can wrap around it so that it hides that. And this ring is going to have a little bit of a design to it, so it looks kind of intentional, and that connecting part is hidden. And there's one thing I also wanted to mention for the tabletop here. This is also going to be in a half, but there's not a whole lot I can do to hide it. So there is going to probably be a seam here down the middle of where it was combined. But I do want to create a storage compartment on one half of this table. So there would be a piece that would have kind of like a finger slot where you can just lift this open, and there would be a storage compartment here. A tiny one, but maybe you can fit pens and, you know, whatever else you want to put in there. And that'll kind of take care of the storage aspect here. The phone slot's taken care of. And I feel like the headphone hook and the cup holder we'll kind of get to that after we've 3D modeled out all these pieces and we've put it together in the 3D software. Maybe we can come up with some refined parts. But yeah, guys, that about does this designing aspect. Next thing we're going to get into is jumping into Maya and getting this whole idea modeled out and ready for 3D printing. This is going to be really fun, guys. Alright guys, I just came out here into the tiny print farm room, and I wanted to show you that I just noticed that one of these Bamboo Lab logos, this was the one I bought from Bamboo Lab themselves, and this is the Micro Center one. They have these little logos. That was interesting, but that's not what I was going to show you. I just happened to notice that right now. But so basically, two side-by-side Bamboo Lab A1 build plates are definitely wide enough, even wider actually, to do the width of the table. But as you can tell, we're missing about this much, and I'm not going to make it so that it's exactly this size up here. I'm just going to keep it this short. My only concern is would a laptop fit on it, because I would like personally to be able to use a laptop on it. Alright guys, so I got a like medium to large size laptop over here, and it looks like it'll fit. It's going to be a real snug fit, but nonetheless it'll fit. That's really, really great news. So what that means for these PEI sheets is that this is the perfect size. I'll make it the width of this table, but I'll go to the edges here of where it prints out. And I actually left this one on here so I can see where this prints out, and it'll be perfect for a laptop to fit on there too. Very nice. Alright guys, so we're here in Maya, and I went ahead and I took pictures of my designs, and this is just the table itself without having turned it into stealth. And up here in the top left hand corner we have the build plate size for the Bamboo Lab A1, which is 256 millimeters cube. We have a bunch of measurements, all the parts we'll need, and some features we'd like to add. And here's our design. As you could remember, we have our tabletop, we got the medium under table bars and smaller table bars, as well as the cylindrical wood, the bottom support bar, assembly screws, that metal holder wire, which it's not going to be metal in this case, and the legs. So let's go ahead and start with the tabletop right here. And I'm going to go ahead in the real world and take measurements with my digital ruler here to know the width of the table, because as you remember in the previous videos, the width of it was able to fit on two build plates, and the build plates extended further. So I have 485 millimeters width. I'm going to go ahead and create a cube. Let's make sure actually we're in millimeters. Nope, we're not. So I'm going to go ahead and delete this cube, make sure we're in millimeters first, because that's the measurements I used. Create a cube. And remember, we got to multiply it by 10 in Maya for real world measurements. Go over to width, and it's 485 for the width. I'm going to turn on ambient occlusion here and anti-aliasing to give us a really nice look in the viewport of our geometry. And since the build plate's 256 millimeters, I'm going to make it 256 millimeters, but we're probably going to have to subtract from it later on as I add some of the design elements, and I'll show you what I mean. So 256 millimeters is the size of the build plates for the Bamboo Lab A1. And out here in the real world, the TV tray, it has a 16 millimeter thick table. So I'm going to write 16 millimeters here. All right, and as you remember, we have a hexagonal shape. So I'm going to go ahead and add that in now. So what we're going to do is go to Edge. I'm going to select the edges. And I'm just going to bevel. And that looks a little too aggressive. I kind of want to match what we've got going on over here. So I'm going to bring that down just a tad bit. Let me look at the photo here. And I think I'll bring it down just a tad bit more. If your dialog box disappears here, you can just click on your object and press T. It'll bring it right back. All right, I think that's looking pretty good. It's a little smaller, so I'll increase it just a tad bit. There you go. I like the way that's looking. All right, and again, as you could remember in the design, we have this tapered edge over here. It kind of gives you the better idea over here. And so that's what I'm going to include now. And I'm going to go over to Edge, select my edge, left mouse button, Control, Edge Ring Utilities, Edge to Edge Ring, and Split. That gives me an edge right in the center. Now, if I were to just grab this and scale it up, it's not going to scale in all the directions correctly. As you can tell, it's kind of thicker here as opposed to here. And so to do that the right way, we're going to have to go to Control, left mouse button, two vertices, and then I'm going to go over to my Move tool, double click it so it brings up the options, and I'm going to go ahead and go to Normals. And now it's going to push it out in the direction that I need it to be pushed out, which is the way the normals are facing. And we'll talk about normals at some other point in time, but they're going to pretty much be brought out in equal distance. And again, if you want to make it so it's not so fast to move, you can increase the size of the gizmo here, and it'll give you a little bit more control over how much comes out. This looks a little rounded. I want it to feel like edgy. So I think I want to bring it out just a tad bit more, actually. I want it to feel exaggerated. All right, that's looking good. I'm going to reset that tool. I'll reset it here as well. Close it so we can get our normal move tool back, but it's huge now, so let me bring it back down. Okay, so that's looking pretty cool. But here's the problem now. We have a 256 millimeter cube build plate, and it's certainly past that now. 256, so as you can tell, we're over the edge of the build plate. So to give it some wiggle room, just in case we make any design changes in the future as we continue to design here, I do want to just bring this down a few millimeters. So instead of 256, let's go down to 253. And we're going to match that here. I'm going to grab this. I'm going to do D to edit the pivot, and V, holding V, to vertex snap. So then I could snap this down to 253 millimeters. And likewise, we'll do the same thing on this side. And I'll show the edges here so you can see what I'm snapping it to. It's that measuring cube that I created. I'm going to hide this measuring cube for now. And I think I like the way it's looking so far. It's nice. And I talked about including a storage and all that over here, some added features, but I think I'm going to leave the features for last. So we're just going to go ahead for now and create the main design elements and put everything together. And that's also going to include the phone slot here. So I'll do a phone slot at a later time. So I like the way this is looking. And I'm going to wait, actually, before I finalize the design and get rid of these CG edges by chamfering them. I'm going to wait, actually, before I do any of that, and have everything modeled out first in its basic geometric form with as little topology as possible, which means as little faces, edges, and as basic as I possibly can. Then I'll go ahead and add details. And these are kind of like the basics of polygonal modeling. We just want to start with basic shapes, as simple as we possibly can, and then we can go up and increase topology and details as time goes on. So I think the next logical step would be to go ahead and create this medium undertable bar. And I'm going to go ahead and actually look at the measurements for this. And it looks like it's 251 millimeters here for this bar here. So I know it's going to differ based off of our designs here, but let's start with the basic measurements here. And we're going to call that a depth of 251. And most definitely, it's going to have to be shorter. And I think what I'm going to do is I'm going to go ahead in the real world and measure from the edge of the table to where that starts and see what measurements I get, and we'll adjust the size of this accordingly. All right, so it's about 34 millimeters. So I'm going to go ahead and grab that measuring cube and create it to be 34 millimeters. And that's how we know what size I'm going to make my bar here. But I need it over here in the top view. Okay, I don't need the grid. I'm going to vertex snap the orientation so then I can bring this up and see how small I need to make my bar here. Now I can just scale in both directions using this scale tool in the Z, and that's looking almost there. All right, I think that's looking good. I did 3705, but those last two numbers disappear. And we're looking pretty spot on there. I'm gonna leave that there. I'm gonna see how far this sidebar is from the edge of the table, and we'll know where to place it there. And I never did get the width of this, so I'm gonna go ahead and get the width of that. It looks to be square, so it's 19.5 in its width. There you go. And likewise 19.5. Okay, and now to see the distance from the edge of the table to that support bar, it is the same at 34 millimeters. So this was 34, that's correct. And I'm just going to go ahead and bring it to this edge and bring this over to this corner and bring it over. There you have it. So that's looking as it should. I'm going to create a center line here, as you would know how I would create it, which is just grabbing the edge, edge ring utilities to edge ring and split. And the reason why it's not going across is because Maya doesn't create edge loops in areas where there are n-gons. And this face here is an n-gon. It's not a quad face, which means it has 4 vertices. In fact, this one has 1, 2, 3, 4, 5, 6, 7, 8. So this is a 8-edged piece of geometry, which means 8 vertices. It's not a quad. So we gotta turn these into quads to be able to get edge loops. But I'll just connect this myself with the multi-cut tool for now. I'm going to try to explain some quirks with Maya as we go along. So I'm going to throw in a little bit of information here and there to kind of explain why Maya is doing what it does. So I just vertex snap this down at the bottom as it should be. And I'm going to hide this measuring cube. And the reason why I created this, as a matter of fact, let's create a center line across as well. But again, we can't. So we're going to create it on the edges. I'm going to go over to my multi-cut tool. This is our most recent tool that we used, so it's right there. I'm going to go to top view and bring this on over. Perfect. So now we have multiple faces with 1, 2, 3, 4, 5 edges. Still, this isn't a quad, meaning 4 edges. I keep saying edges, but we can say vertices, because each corner here has a vertice and there's 5, but we'll leave that for now. And the reason why I created this, I'm going to turn on wireframe, on shaded, just so I have a place to put the orientation so that I can duplicate it over to X. But we don't need to do that right now, I realize, because we can do it later once it's done. And so I'm going to go ahead and start creating this shape. Since this is done in the meantime, I'm going to put it in a layer. I'm first going to call this measuring cube, because that's where our measuring cube is at. And here's a tabletop. Okay, I can leave that as a reference layer so that I can't touch it by just clicking here and making sure it's on R. So it's there, but you can't touch it. Now, to get this cool shape that I want, I'm going to have to grab these edges and bevel it. And that's looking pretty decent, but I feel like in my design here, it's smaller. So I'm going to go ahead and make this a tad bit smaller. That's looking pretty good, but I do want to make it a tad bit smaller. There you go. All right. So that's looking pretty cool. So I'm going to go ahead and take a look at that drawing of mine again and see how it's holding up to the design. All right. So now I want to create that cool design in the center that we have. So there's a couple of ways we can get this design here. Now I'm going to show you the way I'm going to go about doing it. So I'm going to grab the face here and just simply extrude. And instead of using this tool here, I'm going to switch over to scale, and I'm going to scale in all directions. And as you can see, it's going to scale unevenly, so I got to eyeball that. How's that holding up? That's pretty close, but let's make it a little smaller here. And what I'm trying to do is I'm trying to get the edges to be about the same. Let's take a look. All right, that's looking pretty cool. It's about where I want it to be. And I'm going to just bring this out like that. How far? Just to be able to get those cool edges right there. And as a matter of fact, I want to be smart here and just work on one side. So I'm going to create an edge ring and split. And the reason why it's not going across again is because there's an end gone here and here on this side. And I'm just going to go ahead and delete that. Now to get that cool design that I got going on over here, where we do have this face here, but just one edge, we got to tweak the model here a little bit. So to do that, I'm going to go ahead and click the vertice here and vertex snap it over to this other vertice right above it. I'm going to grab both, shift right mouse button, merge vertices to center. Now that should just be one. Yep, it is. And I'm going to go ahead and delete that edge. Now we got this interesting design going on over here that looks really cool and edgy. But I do want to fix this look over here. There's something about this that I'm not quite liking, because this edge comes at a corner, then it turns, and then it has this hard turn there. That's really not what I was going for. So I'm going to try to make it straight like that, and maybe bring this entire thing up so that it looks a little equal. And this angle feels a little bit harsh, so I'm going to grab these verts and just bring it over. There you go. That looks a lot better. Again, I feel like I'm getting some sort of an angle right here. It's real subtle. Now to get that edge the way I want it to look, I'm going to grab this face and bring it over like that. And because it feels like it's getting a little thin here compared to this side, I'm going to grab that edge and just widen it out a bit. There you have it. That's looking good. And I feel like the geometry is able to hold itself better now here without having a huge edge showing up. So that's looking good. That's the way I want it to look. And it's very close to what we've got going on in our design. So now that that's ready, and this is already in the center, its orientation, I'm going to go ahead and scale it in Z, duplicate special. I'm going to reset this. And remember, the duplicate special here is X, Y, and Z. So that's X, Y, and Z. So I'm going to go and create a duplicate in Z. And to combine these as one, you have to go to Mesh, Combine. But still, they're two separate objects. So you just got to do one more function beyond that. And I'll show you by making the edges that are not connected highlighted. And we want to do Display, Polygon, Custom Polygon Display. And just to show you what I did there, in the options box, you just turn this to 8 and check on bordered edges and click Apply. And in that way, you'll see this highlighted edge showing that these edges are not connected. So I'm going to go to vertice mode, select all those verts, because these are basically, this is literally two vertices on one. And to show you, I'm going to go to Heads Up Display here and do Poly Count on. And over here, you'll see all of our information. So if I go ahead and select this vert, and I'll just show you with this one. Over here, you're going to see in the verts as two, because there's one on top of each other. From the right side and the left side, there are two verts sitting on top of each other. So I'm going to grab those, and I'm going to do merge vertices with the threshold very low, because they're sitting right on top of each other. If they were further apart from each other, you could increase the threshold, and it would just bring those together. But nonetheless, this is looking good. The back, I'm just going to leave it flat. I'm going to bring that orientation back to the center. and duplicate in X. So I got to go back, reset the tool, and duplicate special. There you go. When you click duplicate special, it closes the dialog box, but right next to it, here, let me show you. If you click duplicate special, it closes the dialog box. But if you click apply, it'll apply the function, but keep this dialog box open. We don't need that. So that's actually looking pretty cool, if I say so myself so far. And what do we want to design next? There's 2 pieces of wood here. So we use the same design for those 2 pieces of wood, but they are smaller. So let me go ahead and get the measurements for those. And I think I called this metal bar wood because that little metal bar is connected to them. So it's these pieces of wood here. And that's 125 millimeters. So let's get that at 125 millimeters. All right, so I'm going to bring back my measuring cube, and I'm going to put this at a width of 125 millimeters. And these are kind of large, so I'm going to put them at 20, just so I can measure it easier for no particular reason. I'm going to go over here in my front view. I'm going to modify center of this pivot so that then I can snap it to the center. I'm going to grab one of these guys, click Control D to duplicate, and I'm also going to center this pivot, modify center pivot, and let's rotate this 90 degrees. And since we already have it where we want to have it, in terms of the y-axis here, I'm just going to click V in the X and snap it there. But again, we need it to be about this big. So I'm going to go ahead and select it, delete one side. I'm just going to do this very quickly without explaining it. Snap it there, duplicate special in X. And since we rotated it, it's going to not translate that correctly. So if I show you here, duplicate special in X, apply, it didn't do it. It did it in its old orientation. That's because I rotated it in Y. And so it's always good to modify freeze transformations, edit, delete by type, history here, and then it'll work. I know, Maya's got a whole lot of quirks, a whole lot of personality traits, if you will. But nonetheless, I'm going to combine these as one. And I'm going to select those center vertices and merge. Now we've got one piece of geometry in the center. And it looks like these pieces here are a little bit closer than these would be. So for that reason, I'm going to go ahead and take a measurement out here in the real world. All right, so from this edge to where that wood starts is about 20 millimeters. So I'm going to go ahead and create a 20 millimeter cube here for the measuring cube. And I'm going to vertex snap this to this edge here so that I can bring it over accurately. And that's a 20 millimeter distance. And likewise, I'm going to go over here to the top view, and wherever this begins, I will just bring it to the front like that. I will just bring it over to where that 20 millimeter mark is. And there you have it. I'm going to hide this measuring cube, bring this orientation over to the center, modify freeze transformations, edit, delete by type, history. And I'm just going to scale this over in Z. So duplicate special options and scale that in Z. There you have it. Very nice. I'm going to do the same thing for all of them. Modify freeze transformations, edit, delete by type, history. So we just have a cleaned out history. This is where our history is. So let's see if I did the same for the table. No. So you see all the history here, which you can access any of the tweaks that I made in the past or any of the commands I ran on it and adjust. So you have a history in this stack where you can go back and adjust. So it's non-destructive. But I do want to freeze the transformations, edit, delete by type, history, because I don't need to do anything of that nature right now. So I'm going to turn off wireframe, see how this is looking. That's looking pretty cool. I like that a lot. And there's one other thing that I noticed actually. because I expanded this by this much, this is looking too wide. So I'm going to take a look at how wide those were again, and I'm going to adjust it as needed. So the width was 19 millimeters. I'm going to go ahead and create another measuring cube here just for that really quick, and do 19 millimeters. Bring this over, do my vertex snapping, and yeah, we have 19 millimeters here, but it's a little wider than that now. So I'm going to grab that piece and not make it look so bulky. And I like the way that looks. I'm going to do the same for this here. Grab this piece and bring it down. All right, so those are now a legitimate 19 millimeters. I can go ahead and delete this and this. And I think we duplicated in Z, but I'll double check here. Yep, so this should be ready to go there. And this is in X, so I'm gonna do that. -1 in X, put that back to where it needs to be at 1. And now it's actually looking a lot better. I'm gonna hide that measuring cube for a minute. All right, I'm really liking the way this looks. This actually looks a lot better now that it's the correct measurement. And we're gonna now move on towards the center cylindrical bar. I'll see you guys in Maya. All right, so let's move on to the next piece on the list, and that is the cylindrical piece of wood. And did I get measurements for the wood? Yep, it's 292 millimeters wide. So let's grab that measuring cube and do 292 millimeters wide. And this may have to be adjusted later because of the width of the legs. So, and I'm gonna go ahead and get the thickness of that cylinder, the diameter rather. All right, the diameter is about 15 millimeters. So instead of 20 here, I'm going to do 15 millimeters. There you have it. And over here in side view, I'm going to turn off this grid because I don't need it and get this wireframe mode. And honestly, I don't need these this information here. So I'm just going to go over to display, heads up display, and turn poly count off. Okay. Now I'm going to get a cylinder here. And it's looking real tiny, but it's right there. I need the center of this measuring cube, so I'm going to click a face, do shift, right mouse button, poke face. And so now we have the center of one face, which is most likely this side. Nope, this side here. And that's just going to be helpful for my cylinder. So I can just pop that in the middle and make it larger, turn this 90 degrees. And I'm going to get it to about where it needs to be at 15 millimeters. And we want to create a hexagonal shape. So we got our hexagonal shape there. And I do want to rotate it so that it's flat up top. And I held J and it snapped it in increments. So you can kind of rotate in increments here. And I think the increments are in 15 degrees. Yeah. So bringing that back there, now I can kind of increase this as needed. I kind of want this to be a little bit bigger because of the material we're using. But let's also try to get it accurate. So 86.692, what about, and I'll just do 86.61, and there you go. That seems perfect, rather honestly. So we can just turn the measuring cube off and take a look at what we've got. That's great. That is looking exactly the way I wanted it to look. And now we want to make it the correct width. And to do that, I'm just going to go ahead and grab these verts, turn on wireframe on shaded so I can see the edge there. And I'm just going to bring it on over. Same with this side. And turn off measuring cube. All right, we got our center bar. So we're getting there, guys. We're right where we need to be. This would, in its standing position, be close to the user. So it's probably going to be sitting about, snap that vert and bring it right at the edge. It'd be sitting right about there. And let's go to side view here, and it would be right up top, right over here. Okay, that's looking good. Very nice. All right, let's see what we got next on the design. We got the bottom support bar. We got assembly screws. I think I'm going to leave that for later, and let's jump straight to the metal holder wire. So the metal holder wire is in the center here. And the way I'm going to do this, I'm going to throw this in the tabletop and create a reference. I'm going to duplicate this and also throw it in there so that I have one that I can play with over here. All right, so I want to create a square here. So let's bevel that. I'm going to try to get it to look as square as possible. All right, that's looking like a square to me. And I'm going to go ahead and extrude this out. And let's see. What's a good thickness that I feel like would be strong? I'd say 5 millimeters is a good thickness that I feel like it wouldn't snap as PETG. But just to be on the safe side, let's make it 8 millimeters. 8 millimeters would be nice, and I feel like it wouldn't even consider snapping at that point. So I got my measuring cube over here. Let me actually select it, select objects. And I'm going to do 8 millimeters. There you have it. So that's an 8 millimeter thickness that I want to make this be. I'm going to grab that and give it that 8 millimeter thickness. That is actually very thick, and I feel comfortable that that's going to be very supportive. And likewise, I'm going to now bring this forward a bit. As it's shown in the design here, we're going to create this now, and then we're going to go ahead and create that center part. So that looks about right. Let me go over to side view, and it doesn't have to be too exaggerated. I think that's looking good there. I'm just going to bring it forward here to the center. All right, that center bar is looking real hefty. Is it too hefty? Maybe. We'll find out. But it's PETG, and I want it to be real strong. I would honestly like to make it a little thinner to give it like a sleeker look, which, you know what? I will, because now that I remember, there's a design here that I can add that extra 3 millimeters to. So for that reason, I'm going to go back to my side view, turn on that measuring cube, and I'm going to make that 5. I'm going to bring its orientation to the top here. Bring that back up there, and select these. And by the way, I click Tab to give me this circular selection, which allows me to just click once and just scroll the mouse, and it'll select anything I want it to select. But we just need those for this. I'm going to grab this orientation and vertex snap it here so that I can make it exactly 5 millimeters there. Turn off measuring cube, and now I want to create this cool little design here. So all we got to do is create that center part there and bring it out. And since this is one piece and we don't need it to be one piece, I just kind of use this center part as a reference to create this part. I'm going to go ahead and delete everything else. And I'm going to select all those faces, including the top ones here. And I'm going to click Shift and drag and delete. And now we have the reference one there. So if I turn that off, you'll see it. I'm going to go ahead and select all the edges, fill hole. So now that's filled. And now I'm going to go ahead and create a center line. And I'm going to grab these vertices and just bring them out. I'm going to bring it out pretty exaggerated for now. And then I'm going to go ahead and grab this edge and bevel it. And as you can see here, it's kind of a small bevel. So I'm going to bring that in. How's that looking in comparison? Well, it's a little wider. Maybe I can bring it in just a little bit more. There you go. All right, I like the way that's looking, but remember, I do want to create this to be 8 millimeters. So I'm going to grab my measuring cube again and do 8 millimeters here and bring that up. It's just past 8 millimeters, and I did that intentionally. I'm just going to go ahead and grab this part, and I'm going to bring my orientation, my pivot, there to be able to snap it to that cube. And this is looking good. All right. So now that I like the way this looks, I'm going to go ahead and, as you can see, the pivot is right in the center, and we need to just duplicate special over in Z, that blue, as you can find here as well. And it's already in Z, so I'm going to go ahead and just click apply, grab these two, mesh combine, grab that center, merge vertices, merge vertices. There you have it. All right. We got the makings of that metal holder wire, that center bar. And now I feel like we can work on the legs. Now I want to go ahead and create these legs. So I'm going to check the measurements. So the inner leg and the outer leg both are 695 millimeters. So I'm going to go ahead and create a cube. Do the 10 as usual, and we're going to do a height of 695. And according to my measurements here, the thickness is 22 by 20. So I assume the thickness is 20 and the width is 22. So let's do width of 22 and the depth of 20. If we were to just rotate this 90 degrees, this is how the legs would sit over here. And this feels really tall because it's not rotated. But we're going to do all that rotating later. I'm going to hide the tabletop, and I want to start working on the design here. And as you can see, we got our cool little design going on over here, and I'm going to start building out that shape. So I'm going to grab this leg. I'm going to go ahead and cut it in half because I only want to work on one half, make life a little easier for me when it comes to this 3D designing business. And I'm going to select these two edges and bevel it. Now we're going to bevel as far down as we can without losing too much, but I feel like this is actually pretty wide. So I'm going to keep it about that wide. And I'm going to grab these edges and bring that down. Let me take a look at the reference. That's looking good so far. So I'm going to select all the edges here, and I'm going to do bevel. I'm going to turn off chamfer so it doesn't give that diagonal line. And now we can work with this center here. According to the design, looks like that. I did make this a little longer because I do like that look. So with that being said, I think this looks good. We don't need this line. And I'm actually going to create a center line here so that we can play with the shape a little bit later. I'm going to grab this, and I'm going to bring it out a tad bit until I feel like it looks cool to my eye. All right, that feels real cool there. But now, as you can tell, it got much thicker than we had originally intended. And I think it was at about 22. So let me grab this measuring cube and see if it's at 22. Let me modify center pivot to get that pivot back in the center and bring it off to the edge. There you go. Okay, actually this was at 20. The width was 22. And there you have it. See, yeah, as you can tell, it was at 20 right there, but we brought it out a bit to accommodate the design. And I'm just going to bring that back. Okay, hide that measuring cube. And there you go. Let me turn off that and see how that looks. Now in Maya, you can play with normals. And by the way, what a normal is the way light bounces off an object. And so if I had, let's say, a light source right here, and it was throwing a light here, on this edge, where would it reflect off the object? In what direction? And to show you exactly which direction the normals are facing in, we're going to click on our object. We're going to go over here to the shape node, mesh component display, and display normal. I'm going to increase the size here to 5. And as you can see, when a light hits this surface, the light normal, well, the angle it shoots off the object is here. And likewise with all those other spikes coming out of there, looks a bit like a cactus. But we don't need to see that. And the reason why I bring it up is because we see it smooth over here. So I'm going to go over to mesh display, and I'm just going to click harden edge. So now we can see that look we're going to be going for in the 3D printed version. So it looks real angular, and I call it that stealth look. We could also call it the geometric look. All right, now that we have this look going on, do I want to play with this here? Maybe angle it a little bit this way so it has this cool look. I don't think so. That's not something I intend on doing. Also, I just noticed if we go over to the side here, go over to the front rather, we can see that this edge kind of tilts down like that, and I don't like that. So I'm going to go ahead and grab these and just straighten it out so it looks straight and it has a straight edge. All right, you know what? I'm liking the way that's looking. So I'm going to go ahead and this time duplicate special in Y. I'll reset that and do it in Y. Duplicate special. And now we have the makings of our leg. Mesh, combine. And I'm going to merge those verts so that's one. I'm just going to double check. Oh, it didn't work this time. I wonder why. Let's go to display, polygon, custom polygon display. Grab those vertices and merge the verts. Nope, it's not working. That means that these are ever so slightly off their position, but it doesn't look to be that way. Let's increase the threshold to 0.001, and that worked. Okay. Now it is one object. Very nice. So we're going to need 4 of these legs, but I'll create it when it's ready to be created. And we're almost there, actually. We just have a few more things we need to 3D model. A couple, rather. We just need this bottom support bar and these assembly screws. Hey, what's up, everybody? So it is still August 14th, 2024. It is 6:36 p.m. And we're just going to continue here with the Stealth TV tray. And as far as I remember from where we left off, we just have this bottom support bar that we need to create, as well as the assembly screws. And there was a couple of features that we were going to add, which is a slot for the tablet and phone, as well as a storage compartment. So with that being said, let's continue with the legs. So there is one thing that I noticed when making these legs here, and that is there's going to be such a small place for the legs to connect with the screw here. And so I think I'm left with no choice but to leave this kind of a half circle over here. So with that being said, I'm going to go ahead and create a half circle shape from this. I'm going to get my multi-cut tool over here and cut that there. Alright, I got that cut out, and I'm just going to go ahead and select this, go to Shift right mouse button, extract faces, and I want to keep this just so I have measurements, and I'll show you what I mean. And because this is going to be rotating from this point, and it's going to be rotating in either direction, it's got to be kind of like a half circle here. So I'm going to go ahead and create that, but at the same time, I don't want it to look too much like a circle. But I think that's looking okay there, and bring it up. Now I do want to match the length, so I'm going to bring that up just about there. Alright, and that's connected and looking good. It'll be able to rotate like this as needed. As we remember from before, we've got 256 millimeters cubed as the build plate, and we're going to do 256 millimeters. All right, so as you can tell, we may have to do these in thirds, but before I give that option a try, I'm going to rotate this at a 45-degree angle and maximize the build plate space here on the Bamboo Lab A1 build plate. So if I were to just grab a multi-cut tool and put one right in the center, it's so close. It's honestly really, really close to being able to work out. I'd rather just do 2 pieces, in all honesty, than have multiple chunks like that. For that reason, I may just make it a tad bit shorter. All right, that doesn't look like too much of a big difference, and I can double check what it is. So that's a 31.6 millimeter difference, which is totally fine. We're just going to grab these faces. We're going to extrude them in. So I'm going to reduce the thickness, and I'm going to go ahead and run a Boolean. So difference. So that created our cavity. That's looking good. And that's where our other piece is going to sit in. So I'm just going to grab these two, delete the rest, and bridge these over. Very cool. And that's how it's going to sit and fit together, rather. And if you look at the idea I had, I wanted to create some sort of cool design like this. We'll see how we can do that because we've already got a design there. Let's see what we can do. All right, that's looking more like what I was going for. And we got the makings of a leg. And it's going to print out just fine on the Bambu Lab A1. All right, guys, so I'm going to save myself a little bit of time. I'm back to this rotary clamp. And since I've already gotten all the measurements for those screws from Harbor Freight in this file, I'm just going to go ahead and grab them and not have to redo the work. All right, so I'll make sure this screw is through, just like that. So that's where I'm planning on plotting the hole for that. All right, so I moved the pivot to the center of this hole here, and I'm just going to go ahead and rotate that. But I am liking the way that's looking, and we have to be mindful of some washers over here. So it looks to be almost the size of the table leg. So I'm just going to bring it about that big. All right, and we've got another little screw place down here. And yeah, that's looking pretty good. Now we've got a cutout for our cylindrical bar here to sit in. So we are looking good. We do have to create that diagonal bar that goes across here, which looks like this. It's the bottom support bar. Now we have the base for this center bar, and we're going to want to stealth it out. I'm going to go ahead and do a multi-cut like this. Align it with that and bring it a little forward, but we do want to exaggerate a little bit, and for that reason I'm going to bring this back a little bit here this way. And again, I want to align it so it's being moved in the right orientation. This is looking real sweet. I got to grab some of these. Let me do it right now as I talk, so this video doesn't drag on for a super long time. Cool. All right, there you go. So we're getting everything ready to be Booleaned. I still have to create those screws. All right. We do have to create connecting points for this, and I'm just going to extrude this a bit, but I want to see what I'm working on here from the side view. And we're going about that deep. Boolean difference. So now this piece can sit in here as needed. Very nice. All that we've got left now is we have 1, we need to bevel everything. 2, we need to Boolean the screw holes. 3, make the correct 3D printed screw sizes. We need to also create the features, phone/tablet slot. 2, we're going to do the storage. Alright guys, so I think I'm going to continue all this stuff tomorrow. It's about 2 hours and 8 minutes of filming now. I know when I edit it down it's not that long, but I'm going to continue this back up on August 15th, which is tomorrow. It's now 8:45 p.m. and I'll see you in a moment. Alright guys, it's August 15th, 2024 at 7:40 a.m. and in the video it just looks like I jumped to saying the date, but I just wanted to mark in the video where I switched from one day to another. And there are a few things we still need to do. So as a reminder, we're gonna bevel everything, Boolean the screw holes, make the correct 3D printed screw sizes, and we're going to add some screw holes on the bottom of the table bottom bars, which are these things here. I just added that because there are screw holes on the actual TV tray, but we may not need to add them. In fact, I'm just going to add a point where they connect, so I'm not trying to guess where to either glue these parts, or I haven't decided how I'm going to affix them yet, but I'm most likely just going to glue them on. And then we got to make the phone tablet slot and the storage. So without further ado, I'm actually going to go ahead and make this taller. I'm going to make it taller because I do want to add a storage in the tabletop, and I do want to add that slot at the same time. I don't want the tabletop to be too thick, but nonetheless it has to accommodate those elements to make this really cool. I'm going to go ahead and select all those edges, bevel them, definitely make them smaller, and let's do 4. Why 4? I just like to do 4 because it gives me a center line. So you got a center line there flanked by 2 edges on either side. I'm actually going to make this go all the way across. So I'm going to the top view. I'm actually going to turn on shaded mode, leave wireframe on so I can see where we're bringing it up to. After having checked some of my pen sizes, I figured that 192 by 80 millimeter storage compartment should be a good size, and I know I want it to be on the right side here. Go to mesh and difference. So now we have this storage compartment here, and that's going to be our lid. Now we can do that Boolean, and that's looking like it's going to fit perfectly there. If I were to grab all these here and just extend it out, okay, maybe I could just bring these in and line it up. And I think that's looking great. Now, to make sure that the dovetails don't exceed the table width, all right, we do have some extra room to play with. So that's very good news. We're going to run some Boolean functions on that. So grab one, then the other, mesh, difference. All right, that's going to fit in really well. Very nice. We got that intersecting dovetail, perfect. I'm just going to grab these, mesh, and union. There you have it. Very nice. I don't want to chamfer these because I want it to sit real nice and flush with each other. All right, let's go ahead and bevel. 0.15 is good. And we'll do 4. There you have it. That looks intentional. Very nice. Mesh, Boolean, difference. Very nice. So we have a nice big place to put our tablets and phones as needed. I'm going to duplicate these, put them in their layer, and I'm just going to go ahead and grab these here. And extrude it out just ever so slightly. So I'm going to grab one, then the other, mesh, difference. Likewise with this one, I'm just going to click G, perfect. Grab one, then the other, Boolean, difference. Same, difference, edit, delete by type history. Now we're going to bring back those duplicates there and do the same for this side, difference. And we're going to go ahead and grab it and run G, same thing. Okay, we are looking good here. Okay, and let's start working this because I could only put this off for so long. I'm just going to bring these where they need to be. Let's see how far we should bring that in. Okay. So I'm going to just move the pivot to where that needs to be, and I'm going to actually just give it a little bit of a tolerance gap. There you have it. Okay, that's the correct screw size for that one. All right, this thing is looking really cool if I can say so myself. I like it a lot. Now I'm going to go ahead and bevel that. So I'm going to do 0.08 like the other one, and 4. How's that looking? It's looking intentional and nice. Very good. Let's do 4 segments. All right, that's looking good. I like it the way it is there. But let's make sure it lines up with the top one. Oh no, see how thin that is compared to that one? So I'm going to leave the wireframe on and try to match it. I click T to bring this back, this little dialog box. So that looks like a 0.3 maybe. And yeah, this is a little smaller. Maybe we can do probably a 0.35. Now it's looking a little bit bigger. So let's go to 0.32. And I think that's looking pretty accurate there. And let's go ahead and bevel that. 0.32. And 4. That's looking good. All right, now that we selected all the edges, let's go ahead and run a bevel. Bring that on down to, let's say, 0.2, and let's give 4 there. I do want to make this a little tighter, so let's do 0.1. Yeah, that's definitely looking a lot better. Okay, so now this part is really important, where we need to just select everything, go over to face mode. We're going to go over to select, use constraints, and wherever there are n-gons in our next selection, it will get highlighted. And so wherever you see highlighted in orange, there are n-gons. So I'm going to go spacebar, mesh, triangulate. So now this will work well in a slicer software, because slicer softwares have a hard time reading n-gons. They like triangles and quads. So I'm going to go ahead and select all this. And also we need to create UVs, and we're just going to do automatic UVs here. This also helps with slicer softwares reading the files. So this is pretty much ready for a slicer software. I'm going to do modify, freeze transformations, edit, delete by type, history. But I certainly can't leave all my pieces of geometry as unnamed. So I'm going to go ahead and go through the naming process now. So we have stealth TV tray underscore tabletop, and I'm just going to write left. Okay, and we're all labeled and good to go. All right, guys, so pretty much the next step is exporting all these out as separate OBJs, and we're going to go into Bamboo Studio and get this sliced out. But since this video is about 5 hours of raw footage, and I don't know how long it will be after I finish editing it, I think I'm going to save Bamboo Studio for a different video. So we'll just stop here for now, and we'll pick it up probably once we get all that filament that I ordered. So I'll see you out in the real world. All right, guys. So I pretty much have the Stealth TV tray printed out, the mini version rather. But there's just one little problem. And it looks like this fell over. This is that hexagonal center bar. It was doing good up until this point. So honestly, overall, despite that falling over, it was doing pretty good. But this thing's just too thin and too tall to be printed over on the corner of the print bed here. Totally understandable. I get it. I'm not too disappointed. I was kind of surprised that even these little screws that I have over here was printing out okay. Like honestly, they look really good. I'm pretty impressed. Now there is one thing I noticed, that the design element that I created for the bottom center bar, where it connects near to the bottom of the legs, it came out this way. So for sure we're gonna have to print this in a different orientation. And this is all part of why I did this test. So I can test out different ways of 3D printing the Stealth TV tray and kind of see what the best orientations are, see if they fit properly with one another. And I'm really excited to put this thing together and test it out. But for sure we're going to need to reprint this piece here. So I'm going to actually start that now so I don't have to wait for a long time. And I imagine this will print pretty quick. I'm kind of tempted to try printing it standing up again, but in the center of the bed, or maybe just print it down on the bed flat. We'll see. I do know that print times vary, so if you print it standing up, it'll definitely take longer because it's probably going to go slower to maintain accuracy. I noticed that about vertical prints, but the print quality is very nice, except for that part there. But it was almost there, almost there. Now, I don't imagine any of these screws are going to fit together, but nonetheless, we'll give it a try. First things first, I'm going to take off the tabletop here. Okay, how's that bottom looking? It's looking pretty good. It's really nice, actually. Honestly, super solid. All right, first test here. I got my dovetails, and let's see if they fit together. Oh, unfortunately they don't. So maybe this test was too small. I think I might have pushed the limits here a little too hard. Too much of a miniature. All right, so that's not quite fitting together, and that's understandable. It's a really small miniature. Let me see if this lid will work. Okay, so I'm gonna try giving this lid a try. Yeah, I don't imagine this is gonna fit together at all. It's too small. So that's totally fine. I just gotta work on making either a bigger version. I think if I scale everything up a bit, it's gonna help, because trying to fit everything together in such a small scale, it's not gonna work. But I'm glad I gave this a try, or else I'll be wondering to myself, why did I print out a full-size version without first trying this? So I'm glad I tried this out. Doesn't seem to be working, and I don't imagine any of these pieces are gonna really fit together. But nonetheless, we can give it a try. So I'm just gonna grab this piece here and try to fit that together. Hey, what do you know? That kind of worked, but I feel like it's about to break. But kind of to get an idea, this will be like that. And we'll have another one coming down this way. I'm kind of afraid that this might happen on the full-size print, this wobbliness. But then we have this piece, which is not supposed to be fused together, but it's so small that it did. So that's something to note. I'm just gonna cut that. See if I can wrap it around this way. I'm probably gonna have to figure something else out, because if at this scale I'm having a hard time bending it open, then I don't imagine it's gonna be any easier if it's full scale. And I only have a really small slit to kind of bend that piece open and wrap it around here. So I don't think that's gonna work either. So this is all very good stuff. I'm really glad I'm trying this out. Here's the center part. Well, actually, this is one of the side bars. So this would go under the table right over here, but it's not lining up, which is totally understandable. It's such a small scale, but at a bigger scale, I imagine they would work. So I guess I just have to wait until I could print everything out in a full scale. I'm gonna go ahead and try to take some of these supports off. All right, so that's that center piece right there. It's supposed to go in the middle and connect to these parts. Yeah, I got that screw hole down there, and it's just supposed to connect like that in the center of this table. And you know what? Even at this scale, this thing is pretty sturdy. I was kind of afraid that this wouldn't be that sturdy, but even at this scale, no, it's pretty sturdy. And this is that bottom bar. It's really beefy. Let's see. Do I have? No. It's going to probably be on this one. So there's supposed to be a little slot here for those pieces, but let me see if maybe it's on these. Yeah, there you go. So we have a slot here for this piece, and let me try to fit that in there. All right. Yeah, if this worked, that would have been really sweet to be able to see this in action like that. But yeah, this miniature idea, if it worked, would have been very handy to be able to see how this all fits together. This is the width of the table, and that would have been really cool to see. It's slowly fitting together, but it's definitely too tight. But this is how this is supposed to work, and I can see it kind of pushing this lip out a little bit. But nonetheless, I'm glad I gave this a try. This is telling me some things, not everything, because some of this stuff is just too small. A good test that I'm going to run now, actually, now that it just occurred to me, is I'm going to print out every fitting full scale, just a cutout of the fitting itself, and whatever needs to be pieced together, I'm just going to have a full scale little part of it and see if it works. So, for example, I'll just cut off from here, this part, I'll just cut that part off and see if they fit together at full scale. And if they do, then we're looking good. Same with these, including all parts where there's going to be screw holes, and even this here. I'll just cut this little drawer out and print the lid all at full scale, and that way we can see if everything fits together right. I imagine I'll probably be able to still run a test here and see if this is going to hold up under pressure, and if not, we're just going to have to figure something else out. But nonetheless, I'm going to get that sliced up on the computer and we'll get that printing. All right guys, we're here in Bamboo Studio, And so I just wanted to show you what I'm doing over here. I got the full lid. This is printed out at 100% in size, and I just cut out where the lid would fit into, and just to make sure all the tolerances are correct and it'll fit perfectly, and we'll adjust as we go. So this is not going to waste as much filament as if we had printed the whole table like before, but at least I can get a full size test going here as opposed to that miniature, because that miniature, as you saw, didn't really work out. So I took a screen cap of how long everything's going to take. So this is going to take 6 hours and 5 minutes with 123 grams of filament. Not too bad. And I'm going to have to print everything out separately. So this is test C, by the way. I'll show you test B and A as well. The only things I change after putting generic PETG over here, as I always mention, I just use generic PETG. I changed the wall loops to 4. I do 60% infill and gyroid. I found this combination to have really strong results. For the support, I do tree, and then I adjusted several of the settings here. I just don't remember exactly what I did, but if you guys want to see it, it's right here. And I'll also scroll down. There you have it. And this gives me pretty good tree results. All right, and so this is test B. Again, these take up the length of the build plate, so I could only fit this on here, but test A has a bunch of stuff on it, and I'll show you that in a minute. This is gonna take 6 hours and 20 minutes with 108, let's just call it 109 grams of filament. And I did notice something on one of the parts that I printed out on the miniature, that it gives me some sort of stepping here when it angles up like this. Although I am gonna print this out like this, and hopefully the stepping doesn't occur, I do have some other tests on test A, which I'll open up now. And the only way I'll really be able to find out is if I run some tests. So for this, under the table bar here, we have the design standing up vertically, while we have another one here where it's laying on its back, and also the leg is laying on its back. And so why am I printing a leg in full size, one full leg, as you've seen with test B, and here's the other part in test A? I want to see if it's going to be able to hold up the tabletop, and I'm going to kind of bend it after putting it together, and use my strength to kind of bend it and see if it's too wobbly, if it's too weak. We're just gonna have to figure something else out. I also updated this piece here, that little ring that fits around it, the little sleeve, so it kind of opens up from the side here. I did increase the thickness over here because I noticed that on the miniature model it was way too weak. And I just have cutouts here of everything. So here's a little cutout of the bottom piece that I said printed kind of funny on the miniature, just so that I could see if this fits in right. Here's the center bar. I just printed this part out so I can see if the hole will be fitting through with the screws here. I have some of the screws and the washers, the screw cap, and this here is the center of the table where this piece sits in, this one. And I just wanted to make sure that both the front and the sides will fit in just fine. And then I also have the dovetail I'm using for the tabletop, and I didn't want to do the whole thing because I just want to see if it'll fit at full scale. And likewise, this is also the under table part for this piece fit in. And yeah, that's pretty much it. This one is going to actually take a really long time. This one's going to take 16 hours and 37 minutes with almost 300 grams of filament, but it is a lot better than printing out everything in full scale. And so in this way we can kind of test the tolerances out, go forward from there. Unfortunately, this stuff is probably going to just be garbage, but I may keep it for just testing out, maybe seeing if there's any other things I could benefit from through testing this. Also, the little cylindrical bar did fit on the top portion of that leg, but nonetheless, we're going to find out all the answers with this new test we're doing. But overall, these little screws printed out pretty good. See if I could get it to focus. There's a little bit of shakiness down from the middle, but overall, it's looking okay. That was pretty impressive for such a small, thin piece like that. Nonetheless, I'm going to get this stuff taken off the build plate, and we're going to get that stuff printed out. But beforehand, I got to lubricate this guide rail. Let me take that off there, and these little pieces. All right, this is just going to be stored away for now until I get those new pieces printed out. All right, so since this is ready to go, I'm just going to go ahead and do test C. And with the AMS light, you just got to choose which PETG you want and go from there. Very nice. I am happy to say we got test A, B, and C printed out for the Stealth TV tray, and we're going to be able to try that out today. And yeah, we got a full leg in the center there. We got that drawer storage compartment unit, and then like all the other parts that just fit into each other. So we're going to give that a try. It looks pretty good. And so I'm going to get these off now. All right, guys, I'll start out with the one that's most exciting for me. And actually looking really nice. Very clean print. I'm telling you, these Bamboo Lab A1 printers, they do a spectacular job. This is PETG, by the way. And I'm just going to go ahead and start taking things off. And the print quality is pretty good. Let me zoom in here. That's not just pretty good, that's really good. Very happy with that. And there's everything else for you zoomed in. Very cool. Alright, so I'm just going to throw these all in the bin here. Here's the dovetail. And try to keep those together. I'm actually really curious right now. I can't wait. Alright, let's see. Dang. Oh yeah, there you go. It fits. And I need it to fit really snug because it's joining two tables together. So, hey, what do you know? That's great. Very, very cool. Super snug, like I modeled it to be. So there you go. It really matters the scale of something. Very happy with that. Very cool. Okay, so I guess I'm going to just try them out as I go along because I don't want to wait. Waited enough. This is the little sleeve that I printed for the leg. This is the hexagonal bar. It's a little off. I may have to print it standing up, and hopefully it'll work because it is still pretty thin if you think about it. Let's see what else we can get off here. Everything, very nice. Here's the leg. All right, I'm just going to clear the support here for a second so I could test this piece out. All right, there you go. Honestly, that fit in so well. Perfect. And it has that the beginning of that design element there that goes all the way to the center. But that is looking great. This thing is super solid, by the way, in case anyone was wondering so far. But what really matters is this part. So after I put the leg together, I think that's the one I'm most excited about, is putting this leg together. Okay, that worked great. What else do we have over here? This is the part where the bar fits into, but we have some sagging going on. I just may have to make this a little deeper, but we'll see right now. Maybe not. I just wanted to make it ever so shallow so that I can just basically know where to put that bar, not necessarily for it to fit into. Okay, so I did extend the lip up from there, and that should work out perfectly fine. This is for the side. Yeah, it's even in there. So if I wanted to, I can kind of sand this down, but I think it's kind of unnecessary to do that because it legitimately fits in there, and it'll tell me where to put it, so I don't have to worry about placing it anywhere. And yeah, that's looking great. My tolerances were pretty spot on so far. Here's the screw that goes in, and I did notice that the screw gets a little wobbly over here in the printout, but nonetheless, I'm probably gonna have to make these screw holes a little bit bigger because it's pretty tight. And what about this one? This one I printed out vertically. Yeah, I'm definitely not gonna print out vertically because of these overhangs. And so that was a test I wanted to run. And likewise, this one is the front for the center bar. That doesn't fit, so I gotta make these screw holes bigger. Here's the center bar. I'll probably have to make that loose as well. It goes in, it's just extremely snug. Probably means same for the washer here, the hexagonal washer. Yep, it fits, but it's like it ain't going after it goes in. And this is for this bar here, so let's give that a try. Oh yeah, that works out great. That's perfect. Tells me where to put it, and this is the two halves of the table, by the way. So pretty much you just have a guide as to where to put that and glue it into place. So that's definitely going to be helpful. Very nice. And that's about it. We do have this and a couple of other pieces on the other printer. So once that we put that leg together, which I'm really excited for, we can kind of test that out. And then let's head over to the other part of the leg. Alright guys, so this is the other part of the leg. I'm going to go ahead and take that off. That came off nice and easy with this white PETG. Man, that is real sturdy. I'm not too worried about the leg part, like this part here being weak. It's just a connecting point. I'm kind of worried about it being too weak. But nonetheless, let's go ahead and give that a try. How's that fitting? Very nicely. How is it bending? Oh, that is kind of bendy, guys. So if it's hanging on its side in a diagonal way, it might be bending. The only way to tell is if I do what I intended on doing with this thing, which is to weld it together. I'm going to do that actually. Let's see if this fits. That fit nicely. And what about this? There you have it. Let me see if I could. There you go. Wow, that was like a snap fit. It looks intentional. Look at that. There is these two lines here, but I imagine that's okay. Man, that is really, really cool. And it feels a little bit more sturdy. But like I said, the only way to really tell if I weld these together using a soldering iron, which is what I'm going to do this morning actually. But before we get into all that, let me check out the drawer over here on printer number 5. Alright guys, so let's try this drawer. I think this is the one I'm second most excited about. We've got a whole bunch of support material in there, so we're going to have to clean that out. And here's that beautiful drawer lid. It's very solid, so that's going to be nice when it is used as a tabletop. Alright guys, I'm just making note of how to clean this because there's a lot of support material in there. And so I just grabbed my scraper here, and I know that there's going to be an entire table, so I'm not going to be able to reach it from this side, so I'm trying to come up with a technique where I know that that's the case. And the technique I came up with is just holding it and using the corner here. I'm just going to go in and scrape it out. Let me see if I can do it this way. Yeah, there you go. Yeah, it's coming out of there. It's just a little bit left right there. So there you go. That was cleared out. And now we just have the other side. I'm going to do that off camera really quick. Alright guys, so that got worked out. It's actually pretty easy the other side. And so I do have a little bit of a edge here. It's kind of like tapered to meet the tapered edge here. So let's see if it fits. Ooh, that is really tight. I'm not sure if that's going to work. It's also probably because of that support material in there. It's getting stuck pretty well. Could also be because of the PETG. Sometimes it's just real sticky. No, but you could actually see it causing a little friction there. I'm going to quickly sand this and see if I can get it to go in. Yeah, I'm going to have to definitely increase the size here of the hole to let this pass through. So that's something to note. I almost forgot about the hexagonal bar here. So I'm going to give that a try. Oh yeah, that fits like a charm. Very nice. Both sides. Okay, so now I'm going to go ahead and weld this together and see if it holds up as we would like. Alright guys, so I got the soldering iron here ready for action. And I'm just going to make sure that's fitting the way I want it to fit. I'm going to go ahead and start working this. Let me actually zoom in there. Not sure if I've ever done this for PETG. I've done it for PLA. I got the soldering iron set to 450. So it's definitely, I don't know. Usually would want to go in the X pattern, but just kind of going smooth across here for now, making sure I'm trying to get all these points melted together. Let me go on this side now. Let me see if I can get some patterns going here. I do want to just get it all the way welded in there. I want this thing to be as solid as it possibly can as one piece. Kind of worked that side already. So it's definitely feeling real good, but I do want to smooth this out so that that little sleeve I put on there remains strong, or can actually wrap around it rather. So smoothing this out as best I can, trying to make it one piece. Okay, I think we can call that done. And just want to show you what I got here. So let's see, definitely a lot stronger than before. Let me get that little sleeve on there. So I went ahead and I got that little sleeve. I'm just going to fit it around now. Hopefully it still fits after solder welding. There you go. And this is the reason why I wanted to make the sleeve in the first place, because of that work I'm going to be doing there. Now I have two options. I can glue this like this, or I can throw in a piece of filament and weld that together. I just don't know how good that's going to look, but I kind of want to give this a try, throwing in that filament there. I feel like it'll look pretty good. Alright, so this is looking pretty good. I'm going to just try to be very clean with this and just go over, but I feel like it's definitely burning ETG a little bit, or whatever gunk is on there. it's kind of showing. I didn't want that to show. So I'm kind of rethinking that as I go along here. And let's try to put this in there, see how that'll work. It's actually not looking that bad, and I feel like that will hold real well. I'm gonna do the same with this side now. So I'm gonna pop that in and see if I can just get this to be one piece. All right, that's looking pretty good. Now I think I can say I'm officially done with the soldering iron. All right, guys, that is looking actually really nice. I wish I can kind of smooth that out so it doesn't look so welded. I mean, I think I can probably put a little bit more filament in there when the time comes, but definitely this is going to be the strongest way to be able to merge these two together, and it's going to be on the sides there. Ideally, I would have liked it to only have to happen on one side, so I don't have to do it on both here, but I feel like that was also the best way. Now, to give it a little bit of a bend test, let's see here. It does crickle and crackle a little bit, but it's going to be bending in this way because it's going to be sitting diagonally like this, and it's pretty hefty. So I'm wondering if 4 would definitely do the trick. Let's see. You definitely don't want to put real heavy stuff on there. I wish I had a lot of weights, like bench press weights, so I can do a weight test on it, but there you go. A little bit just broke, and I'm wondering now, did the inside break or did the weld break? But nonetheless, I feel like for my laptop or for like a plate of food I'm eating, I feel like it should be able to hold up, but we won't know until we actually print it out. And the tabletop, I assume, is going to be a little bit heavy, especially because I got that drawer unit in there. I feel like this is the best method I've got. If you guys got any other ideas on how to bring these two together, let me know. But nonetheless, I do feel like it's going to be able to hold, especially if there's 4 of them, 4 times the strength. It would honestly be real cool if this worked out in the end, but I don't know. I don't know if it will, but I'm curious enough to give it a try. If it does, that would be real cool. I'm real curious to see where this leads. If it ends up working, that would be real amazing. And I can see that it doesn't really matter how strong these parts are. What matters is that connecting point, especially because it's right there. And I think it'll get even more complicated if I were to have split it up into 3 pieces instead of 2. So I'm wondering what our options are here. I can't really say for certain until I print everything out. So I think that's what we're going to have to do and just give it a try. But it does feel solid. And it's going to be sitting at about that much of an angle. So I think it might work, guys. That's pretty cool. Because it ain't sitting like this, it's sitting up like that. And the other one's sitting this way. And it just might work. I don't know if you guys seen Master of Disguise, but it's crazy. So crazy, it just might work. Besides the screw hole sizes, the tolerance for the drawer, printing it out, not standing up, but obviously on down, so you don't get on the back here, so it doesn't get this thing going on like this one. This one was printed on its back, and it looks great. And I'm also thinking to maybe also make this a little deeper, so that little sag that happens from the support is kind of higher up and gives a better tolerance. Other than those things, all these pieces fit together, and I'm really looking forward to getting our PETG filament so we can kind of get the final prototype going. After having given it some thought, a lot of thought actually, this center part, my idea for it might work very well. Like I said, I'm gonna make that rectangular dowel that's really long, and we'll make the tolerance so tight, and we'll stick these, we'll stick it in the middle, one half going in and the other half on top, and we'll make it so tight, and we'll maybe put some glue in there too, that it's, for all intents and purposes, literally will feel like one solid piece, this entire leg. So that's the goal, and because I don't think dovetailing it or having connection points is gonna cut it. It's just it's gonna bend at that point and snap. Even though this feels like it can take, oh, there's a little bit of crickly, crackly happening, so no, I think doing that dowel method that I'm talking about would be the best way. Here's our design. And we're gonna go ahead and now update our legs here. So let me go ahead and grab these legs. I'm gonna delete everything else because I don't need anything else for now. And I'm gonna create a little ground plane so I can straighten this leg out. I'm gonna put that in a group. And let me go over to Modify, Snap Together tool, grab that and pop it right there. Now I have it flat and it looks to be completely straight. And now I can work on it. Let me turn this over, modify, center pivot. I don't need this plane anymore. I'm going to rotate that over negative 90 degrees so it's completely flat, and we can get to working on this thing. We honestly don't need this anymore, or these for that matter. Let me combine this as one, mesh combine, so I could just grab these really quick, delete them, and let's bridge these together. Very nice. I'm going to pop these out of the group here because we don't need them in the group anymore, especially because it's just one piece now. We've already done the work of finding out the center of this thing, so I'm going to keep the center there. And as a matter of fact, there's a bunch of edges here that got created when I did the cleanup part of this. So I'm going to delete that out. Grab these as well, delete them, don't need them. I just want to have some geometry that's easy to work with when I do this. Okay, very nice. All right, now that we got rid of those triangles, I can kind of work cleanly here. I'm actually going to go ahead and delete this again because I realized I needed it. And I'm just going to fill this hole. I'm going to fill that hole. And I'm going to want a pretty thick wall here. And I think 8 millimeters is a pretty good thickness, but I'm not sure if I'm going to be able to have such thick walls. But I'll give it a try here. So let me get my measuring cube, multiply that by 10, and do 8 here. So that's an 8 millimeter wall. I don't think that that's going to work. It's too, yeah, it's too thick, and whatever's left is going to be way too small. How about let's just do 5. Let's do a 5 millimeter wall here. I'm just vertex snapping it there so I know how thick that is. If I want a 5 millimeter wall and that dowel to be thicker, because I'm not afraid of the walls breaking, but maybe the dowel might break, so I do want to have the dowel thicker. So now that I'm thinking about it, I really am liking the way this is looking. And the only thing I can do is just try it out and see if it'll work. I always wondered if there was a more scientific way of ensuring strength. Like if there's calculations that are done. I don't know that level of math if there is a way of doing it like that. But this is how I'm doing it. Kind of trying it out as I go along. That's about 12 millimeters. And we'll stick with that. I'm going to delete that there. And that's how big the dowel, that's how big I think the dowel should be with 5 millimeter walls. It's totally fine. Let me go in here, and I don't need that. So I'm going to delete it and bring it out. There you go. Looks like the wall there is passing it up. There you go. That's good. Works for me. And with that being said, let's go ahead and fill this hole and extract that face. Modify center pivot. Okay. Now, I'm going to go ahead and just flat out extrude this face here. Extrude out. And I know I want it to be equal distance from each other. So for that reason, let me actually make sure that both ends are shut. Yeah, both ends are shut. So this is going to be our dowel here. And I'm going to modify center pivot to that. And I got to find the center of this. And to do that, I'm just going to go ahead and extrude this out until they're touching, merge, and then extract these faces because they don't need to be part of it. Oh, they didn't work. Let's see. Mesh, combine, merge verts. That should have worked. Nope. Huh, wonder why it's not working. Modify, freeze transformations, edit, delete by type history. Let's try it now. Nope, it didn't work. Very strange. Let's just do them one by one. That ought to work. If it doesn't work, I'm surprised. All right, that worked. I don't know why my does that sometimes. Mesh display, reverse face. Okay, let me do a center there so I know where the center is for this guy. Very nice. Now we can just delete that face. We don't need it anymore. All right, with that being said, let me grab this and extrude it out. I want to give ample support for where this hole is at, especially because I got to make those screw holes bigger. Again, I like 8 as my number for strength in terms of how thick something should be. So we'll go, we have to do 10 here and do 8 millimeters here. As long as we're cleared for 8 millimeters, yeah, we're definitely good there. This dowel is going to be nice and sturdy. I could go even further out. Let me extend the length of that. Zoom in so I can see it. And yeah, there you go. Very cool. All right, very nice. So we don't need that measuring cube. I'm gonna actually go ahead and delete this stuff and just create a fill hole. And why am I doing this? Because I'm gonna be booleaning it anyway. And again, I do want to give it a slight bit of tolerance. And out here in the real world, I don't know if you guys remember this thing I did, the tolerance test. Since we're doing somewhat of a screw, and there's a little bit of a hexagonal pattern, I want something that's somewhat tight. So I know that when I stick it in, it's going to get jammed in there and it's not going to be able to come out. And 0.05 looks like it'll do the trick. Let's try it with the screw here, or the square rather. Yeah. That's what I want. I want it to go in and not come back out. So we'll go with the 0.05 millimeter tolerance, but I don't know if Maya has that ability to go that small. Let's see, because it'll just say 0.1, 0.05. Yeah, it doesn't have the ability, but I'll go as much as it can, which, let's see, if I put 1.1, yeah, no, it's just sticking at 0.1. But I could find out what a 0.05 is just by finding its half. There you go. And this here is what I need. This is the tiny little 0.05. Could delete that. Very nice. All right, and to kind of fill out the cube here, just grab those edges, extrude up, and just so I can see what's going on, I'm going to go to Polygons, Custom Polygon Display, merge those verts, fill that hole. Very nice. So this is a 0.05 millimeter cube, and that's what we wanted to see. And this is the tolerance that we want to have. So what I'm going to do is just vertex snap that there and bring that to the edge. And I'm going to duplicate this so I have the original one, and I'm going to make this one bigger so that I can boolean out 0.05 millimeter tolerance. So modify, freeze transformations, edit, delete by type history, and let's see how big we need to make this. 1.1, way too big. 1.0083. There you go. 1.0083 is where we need to be to have that amount of tolerance. So with that being said, let me grab this, delete it, and we can start our booleaning. Let's do modify freeze transformations, edit, delete by type history. Grab these, mesh, boolean, difference. All right. So now we have the holes of where this dowel is going to go in, but I want these things to interlock. And to do that, I'm going to go ahead and first edit, delete by type history, and I'm going to grab these guys, delete them. Let's go halfway, and let's see if I can just bridge these together. Bridge. Nope, it's not allowing me to bridge for some odd reason. It should be able to bridge. Ah, here's where the issue is. There must be, yeah, so they have one extra vertex right there. Oh, okay, let me delete this face. There's another one there because of the old vertex, and that should actually work. Bridge, yep, there you have it. And I just wanted to go ahead and find a halfway marker for this. There's that, and we're gonna have to do the same for this side. Let's see if it'll work this way. Bridge, nope, didn't work. So let me do the bridge here, and since I know what it is, I'm just going to turn on vertex mode, grab all these verts, and click backspace, so any rogue verts will be caught, and see, the bridge is now functioning as it needs to. Find the halfway point there, and it looks like it's good to go. And why I did this? Because I want them interlocking with each other at the halfway point. And let me see, which one do I want to be the outside shell, and which one do I want to be the inside shell? We'll have the top coming down. It really doesn't matter. As the outside shell, give it a tiny bit of tolerance, just a tiny bit by eye, just about that much. Well, this side has a shell coming this way, and again, we're going to bring it all the way to the other side so it's interlocking, and just ever so slight tolerance. Do I still have that cube? Do I need that cube? Let's see. No, I think I might have gotten rid of that cube. Okay, and just give it a slight bit of tolerance there, just ever so slight the other way. So there you have it. And I did realize that the Boolean part here extended a lot further out in this direction. I'm going to extend the size of that scale tool And so I can just scale it this way. There you have it. That ought to do the trick. Let me bring the scale tool back down. All right. Okay, so what we've got going on is, let me separate these mesh, separate. Let me grab everything, modify freeze transformations, edit, delete by type history, and modify center pivot to all these things, including that. Oh, that one is already. So if you look at this, we have a place for the dowel to go in and for this to interlock here. And likewise, this has a place for a dowel to go in and interlock there. And for all intents and purposes, this thing is becoming one solid piece. So this ought to give the strength we are looking for. As for the rest of the changes we're going to make, which are here, I'm going to hold off. This is the rectangular cube dowel, which we just did. So I'm going to X that off. That's X'd out. So I just created those parentheses there to show me which ones still need to get done. So we need to enlarge all the screw holes, deepen the connecting points for under table bars, and increase the drawer tolerance. I'm going to wait on those things. I'm going to do these one at a time. So I'm going to go ahead and get these printed out. We're going to try it and see how that works. Is there a screw hole on here? Yeah, there is. I'm wondering if maybe I should make the screw holes bigger now. Yeah, I think I'll do that. All right, I'm not making all the screw holes bigger, just this one since we're working on it. I went ahead and I brought in a screw so we could kind of see what we're working with here. I'm gonna rotate that 90 degrees. I only brought this in so I can kind of see what our screw size is, so I don't need that top there. So let me grab this and I'm gonna find the center to the hole. And how am I gonna do that? I'm just gonna go ahead and select the edge here, the perimeter. Two contiguous edge isn't quite working the way I want it to, but let's see if I can just make it happen. There you go. Delete the rest of that stuff that we don't need. We do not need any of that extra stuff. And nothing from the center either. All right, there you go. Let's extrude that out. And I'm gonna go ahead and go over to faces and extract those faces. So now that I have this, see how there's flipped normals here? Let me actually display and see if there's any disconnected parts. Yep, there's some disconnected parts there because of those flip normals. So I'm going to go to Mesh Display Conform. And that should flip it around for me. And now that we have that, I can just grab these guys and go over to Vertices and merge to center. So now I have the center of that hole and I can kind of measure how big that tolerance is. That's actually a pretty decent sized tolerance, but I guess it's not enough. Let me delete this. I don't need this anymore because I found the center now. That's a pretty decent sized tolerance. I'm kind of curious what that is, how big that gap is there. So let me bring over this cube, this measuring cube that I created, and let's take it to as center as we can get it just by eyeballing it. Let's go 0.1. That's almost a 0.1. So if that's giving me trouble, let's just do a 0.2. Let's have a nice big tolerance gap there because these screws don't need to be tight per se, and I need these to be kind of loose. So let's do a 0.2, and to do that now I'm just going to go ahead and grab all the vertices here and scale. And when I do that, you're going to see I'm going to need to adjust. They've come out, if we go to the side view, because I'm scaling in all directions. So I'm just going to go ahead and deselect these, come over here and vertex snap it so that it's flat again. Likewise with this side, vertex snap it here so it's flat again. And that all looks good to me. Very nice. We can delete that screw, delete that measuring cube. We got a 0.2 millimeter gap, a nice connecting point over here. I'm actually very hopeful that this is going to work exactly the way we need it to work. All right, I'm really excited to try these connecting points and see if they can hold up. But I do want to clean up this scene, and we'll do all the other tests later, all the other parts rather. Edit, delete by type history. There should only be 3 pieces of geometry in this scene. So I'm going to grab those and delete the rest. So I want to know what this is called. So this part is called that. We already named it, so I'm just going based off of the old naming conventions we created. Bottom outer leg left, and let's call this the dowel outer leg left. Okay, I'm liking how this is turning out. So we're going to go UV automatic. So we have UVs for everything. Modify freeze transformations, edit, delete by type history. Okay, and we're just going to export these out one by one. I'll see you in Bamboo Studio. I do realize there's one aspect to this that I forgot to adjust, and that is the tolerance of these guys here. So to do that, I'm going to grab this, duplicate it, let me grab that and delete the rest. I'm going to hide this one. I want to make sure I see what I'm doing, make sure it's fitting together properly. All right, so how about a 0.1 millimeter gap? We can also just do a 0.5 again, or a 0.05 rather. Let me bring this over and let's go to the side here. And again, to get that 0.5, we have to split that up, 0.05 rather. And let's get that tolerance the way we want it. Okay. So let me go ahead and extrude that out, or scale that out rather. Yep, that's pretty close. I think I'm gonna just adjust it a tad bit. You know what? I think that's good for now. We'll just test that out and see how that works out. Grab this, delete it, and now we have what we need. And you know, there's one other thing I forgot to check, and that is for n-gons. So select, use constraints, next selection, go to faces, select end-sided, select, and because my arrows show up my gizmo, I know there are some, so mesh, triangulate. Likewise with this one, I'm going to go to face, and yes, there is some, spacebar, mesh, triangulate, and let's check the dowel. I'm going to go there, select, and yes, there are some, so mesh, triangulate, close and reset. We're good to go. I'm going to actually do the UVs one more time. Modify freeze transformations, edit, delete by type, history. Now I'm going to export those out again, and I'll see you in Bamboo Studio for real this time. All right, guys, now we're here in Bamboo Studio. This object is clearly too big for this, but we already know that. So let's go 90 and let's do a 45, and that should work, but I know there is some tree supports that get built out, and we're going to need to work around that. Let me check my strength here. I like to do 4 walls at a 60% infill with a gyroid. And for supports, you know my support settings I showed you in previous videos, but if you want to see them again, here they are from top to bottom. Let's give that a slice. It's PETG here, which is the material I'm going to use for this. Someone had suggested using PLA, but I want to stick to PETG on this for its strength and heat resistance, just in case I leave the table in front of a window or a door that has sun beaming down on it. It will make it warp. I've definitely experienced that before. So this is looking good. We got some tree supports in there. That's going to be fun to take out, but nonetheless, that looks great. I'm going to go ahead and export all. All right, and let's go ahead and do the same for the bottom part. Yes, I know this is too large, and we've accounted for that. 45, that ought to do the trick. It's still out of bounds. Yes, it is. This one's a little bit longer. So let's see how we can fix this. Bring it out there and slice it. Let's see if we're going to have any issues with the tree supports. Yep, it's going just out of bounds there. So let's move it over a bit. Slice that. Oh, it's just going just out of bounds there. Maybe I can move it over just a tad bit without having it go over. Almost there, just a tad bit over. Hopefully we can make this work, right? We're not getting any error codes that it's going out of the build plate. We're really pushing the limits on this, guys. Hey, there you have it. It's in bounds as far as I can tell. And that's looking good. Let me see. It's just right on the edge. Let me see if I can just move it over ever so slightly. It didn't give me an error, but hey, I'd rather be careful here. And how's that looking? Better. It's in bounds by a little bit. And yeah, I'm feeling good about that. So I'm going to export that out. All right, guys, I'm bringing in this dowel. Just going to use automatic there. That's looking good to me. On a bed slinger, you want the x-axis to go more so than the y here. I don't know if it matters anymore because I think that was done to save the belts. But since this has a metal Y guide rail, I'm not sure if that even counts anymore, but nonetheless, I'll make it go in the X, meaning you want the X to work more than the Y. And yeah, I think that's looking good. So we're going to give that a slice. Very nice. That's going to take only an hour, which is great. I'm going to export that out. And guys, I think I'm going to start the print, and I'll see you out there to wrap this vlog up. Guys, so we're out here. This is printing out real nicely. We got about 2 hours and 19 minutes left on this print here, And this one's almost finished, actually, at just 59 minutes remaining. And I kind of wanted to show you this piece here. This is the dowel piece that we ended up printing out. And one thing I wanted to mention is that I printed it out on the printer. I actually used that printer down there because this one still needs a lubrication. But I printed it out sideways like this and not up like that, so I can get my layer lines printing out from left to right. And what that does is it gives me a lot of strength. Like, you can try to bend it as much as you want, and I mean, at a certain point I'm sure it'll break, but certainly not as easy if the layer lines were going left to right in this direction, because then you could snap it much easier. But because they're going from left to right, it's definitely stronger, as you can see there. But nonetheless, I just wanted to mention that. And dowel's looking real good, real strong. All right, guys, now it's 6:43 p.m. and I wanted to wait till this stuff finishes out printing. And so this white one finished out, and it came off so nicely. And I kind of just wanted to show you what we're working with here. It's looking pretty good. We have some tree supports in there, and hopefully it's gonna be easy to clean up. Let me actually go in with my needle nose pliers. Yeah, with these tree support settings that I got going on, they're pretty easy to clean up. I just don't know if I'm going to be able to reach all the way in there with these. It's pretty deep in there. So I got to figure out a way to kind of go in there and take these out. And there is a little bit of sag up top, as we've seen with these tree supports. So I hope that doesn't cause issues with the tolerance, which I'm pretty sure it will. But I'm going to go ahead and clean these tree supports out and see how that works. Alright, guys, so I pretty much went in with my tweezers. I went with the back of my tweezers here, and I just loosened up the tree supports. After they were loosened up, I just went in and I yanked them out like that. I also did stick the dowel in there, and it's in. I'm not going to push it in any deeper, because once it goes in pretty deep, I don't think it's coming out, and that's exactly how I wanted it. These walls, I feel like would hold up really well. They feel very strong, so I think we're definitely on the right track. I'm really happy with this so far. It's really strong. I feel like it's gonna hold up real well. Yeah, it's a little flexy, a little ever so slightly bendy, because it is PETG after all. There's a little bit more give than, say, PLA. I'd say it's more bendy this way than the way it's gonna be used, and it's going left to right, so we know we're sitting pretty with that. We have just a little bit more time, 46 minutes, for this to finish up, and once that's done, we're going to be able to test this out, and I am really excited to see if this is going to work, and I'm pretty sure it's going to work. And this thing is almost done too. It's at 93%, and we're nearly there. The Lazy Day tray printed out on the Creality CR6 Max. Super cool. Alright, guys, now this finished up too. By the way, it is 7:36 p.m. just so you know the timestamps of everything. And man, I really love these printers. Wish I can get a nice shot with a bunch of detail. There you go. Wow, look at that. That is seriously gorgeous. But nonetheless, let's get this thing off. It's still hot. Hopefully it comes off easy. It burns my fingers to touch the build plate. It's that fresh off the build plate. So I'm going to wait a second and then take it off. Alright, guys, I'm just going to continue here. Alright. Very cool. That is looking real nice, guys. Hopefully the screw hole's big enough now. We've got a little bit, just a little bit of support material there. Tree supports, which come off super easy. I feel like I should probably clean off some of that. Alright, now we're back here, and let me see. I think that's as good as it's going to get. I'm going to try to clean up some of that so it's smooth. And again, we do have tree supports in there. So I'm going to go in like last time with the tweezers and just push them aside and yank them out. There you go. Looks like there's just a few broken ones in there still. Alright. Wow. Honestly, these printers are so amazing. How far 3D printing has come. I know I say it a lot, but I just appreciate how far this technology has come. But nonetheless, this is the other part that's going to fit into here. So let's see how that works. Oh yeah, that's real snug. So I'm not going to force that in just yet without having put this in. So let's go ahead with this. Let me get to a place where I have a better view. Let me probably bring this back. There you go. More area to work with. It's nice and tight. I got my hammer here. I don't even know how far in that went. That's something to note. That doesn't look like it went deep enough. Let's see. Yeah, this thing is probably not going to need any sort of glue whatsoever. Yeah, I feel like that went in all the way. Some of this section here got a lip because of that, so I'm going to go ahead and just cut the lips off here of the dowel piece. Yeah, there's more there. Okay, then we're just going to grab this piece and stick that through. Did it bend? Or is it just occurring to my eye in that way? No, it didn't bend. Alright, this is going to be the hard part. How to do this. I just really hope I can do this the smart way. So, it's going in. I don't know which way it is, but one way or the other, I feel like it's giving me a little bit of a struggle now. And I just have to do this really carefully as to not break anything. Let's see. Alright, we're almost there. Alright. I heard something break. Oh, there it is. That broke right there. Okay, so that tells me this area here needs to be sanded down or given a little bit more room for tolerance because of the sagging that occurs. So I'm just gonna keep going here. We're nearly there, guys. We just have that much more room. All right, it's fully through. Yep, it's a little unfortunate that that piece broke off there, but let's see here. How's it looking here? It's definitely bendy, but I honestly don't think that thing's gonna give very easily. Yeah, it's definitely bendy, but that dowel in there, it's gonna hold up. I kind of want to bend it as much as I can. I don't think there's gonna be that much weight on it anyway, but I feel comfortable about that. Again, for all intents and purposes, it's one piece. I just wish that part didn't break, but unfortunately there was too much pressure because of that. So now I know, and I gotta kind of give it a little bit more wiggle room. Can I pull this apart? It's highly unlikely, and I feel like this is going to be our best bet nonetheless. So despite it breaking in the back, the dowel is still going to do its job. Again, nonetheless, this is going to work out just fine. I was seriously not expecting this part to break off. I think one of our best bets, again, is to increase the tolerance, but maybe even making these walls thicker. But I don't like the idea of that, because the walls here I think are just for aesthetic, to cover up what's being put together there. And even like this, it's still strong, and I'm kind of pulling it apart as I'm making it bend here, and this ain't going nowhere. This is one solid piece, if you ask me. And let's try that screw hole. Perfect. Here's the screw hole that I adjusted, and it works great. Here's a screw hole I didn't adjust, and that ain't well, it's kind of going in, but it's gonna get stuck. So, but this one here goes straight in, enables it to turn as it needs to, and I think we're looking really good with this. I would say, guys, that overall this was a success. We have a little bit of tweaking we need to do now, but even the hole there is perfect, so I can start adjusting all the other holes accordingly, except for some where I need it to be kind of stiff in there. But this was something I definitely was not expecting, and I'm glad I did a little prototype here to test it out. So I'll definitely need to increase the tolerance in that area and maybe just glue it together just so that doesn't happen. I don't think any of that happened on the inside with the dowel. That thing's really strong, and the seam is so small. I do see that this is kind of raised just ever so slightly here, just ever so slightly, and that's because it needs a little more tolerance there, and that wall, it's not thick enough to support too much pressure. But nonetheless, that's looking great. Very happy with this result. Super good. This thing is going to be how we make the leg for the Stealth TV tray. Awesome. All right, guys, so we're here in Maya, and this is the isolated leg that we were working on. And the issue came when I had hammered this part in to here. This wall broke. So with that being said, we're going to have to make this a little bit smaller so that we can have a little bit of a tolerance gap for when this thing sags because of the tree support. So with that being said, I kind of want to see where I was at with the tolerance here. So I'm going to duplicate that, bring that over. I'm going to throw this in a layer. I don't know what this layer is for, so I'm going to just delete that one. And let's hide this. I'm going to bring this back to where it is. And I'm just going to go ahead and just delete parts that I don't need. For example, I don't need the dowel in the center, so I'm going to delete that dowel. Let's go ahead and open the multi-cut tool, and let's see if the options are where I want it to be. So delete the faces, the back face. Yeah, so what all that means is when I select this and I do a cut, it's going to cut in the direction where the arrow is pointing. In this case, it's pointing up. And there you go, and it deletes whatever is past that. So I'm going to do the same with this one. I got to select it first, jump into the tool, and delete that. And that kind of gives me a real simple way of just isolating what I want to work on. So with that being said, I kind of want to see where I was at with the tolerance as mentioned before. And to do that, I'm going to duplicate this again, put this in the layer, and I just, again, want to see where I was at with it. So let me grab this, delete that. So let me grab this here, delete it, and take a look at where we're at with it. And you know what? Let me isolate that, take a look at that. We only need this part, so I'm going to delete that as well. And maybe this way we can see how much of a gap we had. Yeah, that's a pretty tiny gap. So I think where we had it, where the gap was we kind of let it be 0.05. So out here in the real world, we have our little tolerance tool, and this is kind of more closely resembling the shape that we have with that piece that we're working on. So I kind of want to let it go in and out freely. And this one more or less enables that. So I don't want it to be too loose, like where we're at with 0.2 millimeter tolerant. I feel like that's a little too loose, but I feel comfortable doing maybe a 0.15. Because right now we're at a 0.05. We could also try a 0.1, but I don't want it being too tight. And that fits in and comes out pretty easily, but there is this, sagging that occurs because of that tree support. So what I'm going to do is just go with a 0.15. All right, with a 0.15 in mind, let me make sure I'm in millimeters here. Yep, I am. I'm going to grab a square here, or a box, or cube rather. Multiply this by 10 because that's how Maya's real world scale works. 0.15, and we're going to bring that over here, and I'm just going to center that over there. I'm going to snap it to that curve there, which is the curve for the inner part, if I'm not mistaken. Yep. And from there, we're just going to go ahead and modify center pivot. And I'm thinking that we just need to grab the outer parts here like that. And then we could just scale. We can scale down to where we need it to be at. We have some funky thing going on here. I don't know. Let's see. Maybe I can reset the tool. All right. That should actually work as it's supposed to. Sometimes there's some history left on the tool, so I just go ahead and I reset it. All right. So I'm going to go ahead and scale that in, and that looks about right. I gave myself a little extra gap there, but just to be safe, I'm going to bring that in to where it needs to be. Yep. That's about perfect if you ask me. And that should give us the tolerance that we need. It'll go in without snapping anything, hopefully, and we wouldn't need to do it again. But nonetheless, we're gonna print this out and give it a try. Since we're scaling in all directions, this is gonna be off a little bit, so I'm gonna show you what I mean by that. So as you can tell, it kind of has this gap now because it's scaled not only in X and Y, but also scaled in Z, and that's Maya Z. Z is, let's say, through, and Y is where Z for what we're used to seeing in, say, slicer softwares. So nonetheless, I'm bringing that through, and that looks good to me. We got that nice big gap, and we have to attach this back to the bigger part now. So we really don't need this extra one recreated. I would want to just print this part out and see if it fits in nicely. And that will, allow us to gauge with very little filament being used whether it worked or not. So I'm going to go ahead and fill the hole here. And let me grab this one. Let me extend this out just a tad bit and fill the hole there. And we're just doing this so we can see if these fit in together the way they need to. And I think that's going to be real nice. But nonetheless, let me... all right, so I just put that in a layer, and we can move on to some other parts. As you know, here's our list of to-dos, and I say as you know because some of the previous stuff we worked on. So I put a lowercase x here because I did adjust one of the holes, which was this one here, but I didn't do it to any of the rest of them. So what I'm going to do I'm actually going to just delete this. This little piece that we created, I actually don't need it. So I'm just going to delete that. We have the tolerance test here. I'm just going to name it tolerance test. And we can go ahead and duplicate this and, you know, remove it from the layer so it doesn't go back in with it. And I just need this cylinder where the hole is at. And to do that, I'm just going to go ahead and select everything, deselect everything around it, and I could just go ahead and do extract faces. All right, guys, so we have this enlarged hole that we need for all the other parts that we're going to adjust. So I'm going to go ahead and open one of those files. And as a matter of fact, we have our cutout test over here. So all those pieces we cut out, we can kind of take a look at them and adjust as we need it. So we don't need this anymore. We're not going with that idea. We don't need that piece. These actually worked really well, so we don't need to worry about those. These screws, we're not going to touch them. We're only messing with the screw holes. This piece worked out pretty good. I'm kind of thinking whether or not I should increase the tolerance, but it worked well, so I'm not going to mess with it. This also worked very well, and this is the screw hole we're going to need to adjust. This one, I feel like we can adjust it slightly because we do want it to kind of get stuck in there. These worked very well, so we don't need to mess with those. It was only these pieces here. Let's see what else. We have different parts of the model here. This we don't need to mess with, and so we can delete that. And this piece we definitely need to adjust. So I'm going to go ahead and adjust the screw holes, I think at a later time, especially because we don't need them right now. So I think we'll adjust the screw holes as we get closer, but I do want to retest this piece. This is the piece where I'm going to need it to get stuck in there. So let me actually grab this piece, copy it, and paste it into here, and use this as a guide of how big we need to make the screw hole. And again, to find the center of this thing, it's pretty simple. So I'm just going to go to one side here and go to the edge. I may not be able to just grab all the edges. Oh, but this one worked. So I'm just going to hit Shift and extrude. And I'm just going to say Control left mouse button to vertices. Then Shift right mouse button, merge vertices to center. And it doesn't need to be perfect. I'm just using it as kind of a guide. There you go. And we can go ahead and just delete that. We don't need this at all. All right. Now that we can see how big we need to make this hole, we can go ahead and start working on that. Again, I don't want to make it too big, but I'll go halfway there. So I think right there is a good medium point for me. And we're going to test print this piece out. We're going to call this tolerance test 2. And we're just going to leave this as a lowercase x because we need to do it for the rest of them. So deepen connecting points for under table bars. Okay, so we're back here, and this was the connecting points for the under table bars. But since these are in pieces, let me actually work on this piece over here so that it goes in and it stays in. And I think if we just bring it down just a tad bit, I think that's going to work just fine. But at the same time, I don't want to print this entire piece because it's a lot of filament to just be using up. So I'm going to go ahead and cut this a lot smaller. And let's see how I can make this straight because it's at a diagonal right now. All right, so I'm just going to straighten this out as best I could after bringing that plane in, just so I know I got a straight piece that I'm cutting up. I'm going to increase the size of my rotation tool, and that's looking good. So I'm going to delete that plane that I used as a guide and cut this up a little bit more. So we definitely don't need that much. Got my multi-cut tool so I can do that cut that I've been doing. All right, and there. And let's see about the bottom. This doesn't go too deep, so I don't need to worry about that. I'm just going to go ahead and cut that much. All right, that's looking good to me. So there's a bunch of edges that are going to remain from the triangulating we did last time. And I just want to go ahead and delete it. It's just going to create unnecessary geometry. Probably same with this side. Yep. All right. Very cool. So we're going to grab one side and the other and bridge it. And we could just grab this and fill hole. All right. That's looking really good. We can go ahead and test print that out. We can go modify, freeze transformations, edit, delete by type history. Go back into this scene, paste it in. All right. And we have pasted. So These are little prefixes that come in when you copy and paste a piece of geometry into Maya. So while this is selected, we go over to Modify, Search and Replace Names. For search for, we type in pasted __ replace with. We have the $sign. Make sure all is selected and you just click replace and it deletes that prefix. All right, now that we have that finished up, we can kind of go in and do this drawer unit. Let's see what we have left on the list. On the list here, we have deepen connecting points for under table bars. We just did that. Then we have increase drawer tolerance. We're going to do that right now. Hexagonal pole should be smaller. Pole hole. But I think we're just going to leave that for now. Mark it to know how deep the dowel went in. Oh, I see. Okay, and make tolerance slightly larger. And we did this as well. So on the dowel, we can do that marker, but we're not going to do that for this because it's nothing that we need to test out. I just want to create a little line, a little slit on the dowel here. So I kind of want to just go in and make like a small little slit, and I could do it now. I just don't want to make a huge slit to the point where it'll weaken the object. I'm going to vertex snap it here. I just want to go ahead and isolate the dowel. And I know that, so this is where it kind of pokes out of this section, and I want to know because last time it was a little hard to tell how deep it went, if it was deep in there enough, or if it was, you know, sticking out just a little bit. So I'm going to go ahead and create a little bit of a bevel here, turn off chamfer, and this is moving way too quick. I could slow this down. There you go. And we only needed about to there. Now I'm just going to go ahead and grab this center piece here, center edge, and bring it down just ever so slightly. I don't want to do it too much because I want to maintain the strength there. So that should be about fine. I actually want to bring this in a little bit more to really accentuate that. And in that way, I know when this is, let me harden the edges. When this is in there, I can tell, hey, it went in where it needs to go in. So that's actually looking pretty good too. And you know, since we already did it, let's might as well just mark it off. And we did it. Yep, we already marked it off. All right, very nice. And let's work on the drawer. And since we don't need another one of these because I already have one, we're just gonna go ahead and work on making the hole over here larger. All right, so I'm gonna grab this guy, bring it in, and the tolerance is very tight there. Let me find the center line so I can line it up properly. And to do that, I'm gonna go ahead and create another square here, just bring it over, or a cube rather. And I'm going to extend the vertices and snap them to the edges. And with that, I can now just grab an edge, create a split there, and do a multi-cut, but we need to reset the tool so it doesn't cut it like we have been using it to do. Select our object. Let's kind of match it up as best as we can first. There you go. And I'm just going to vertex snap that there. So we have the center of that object. Let's do the same thing with this here. I'm going to delete this center. All right, and we're not going to want to line it up to these edges because these are where we cut them, but rather these inner edges. So let me line it up there, there. And from there, I can grab the multi-cut tool, do a center cut there, and again, grab that multi-cut tool and do a cut this way. Now we're going to snap that together. And that's looking good. Let me bring this over, snap this object here. And as you can tell, the tolerances are extremely tight. Out here in the real world, we have this square and it goes in real nice and easy because, you know, that drawer is pretty much a square. But there are a bunch of tree supports that get built up in the place where the drawer lid goes in, so there might be some sagging. I'm considering doing a 2 where there's ample space, or even a 0.25. I think I'm going to go with a 0.25, and if that's too loose, we can go ahead and fix that, but I do want to make sure I have ample space, and this 0.25 feels real loose. I'm kind of tempted to go 0.3 just to be extra safe, because there's just so much tree supports that get built up in there. As a matter of fact, let's do 0.3. Let's just be very safe with it and give us ample room to kind of move around with that drawer. So I'm going to go ahead and create a measuring cube, and we're going to multiply this by 10 because that's just how Maya works for real world scale. And we're going to do 0.3, and let's see if we can get that looking the way we want to. That's actually more than 0.3 there. I wonder if that's a 0.32. Maybe a 0.35? Looks to be a 0.35. Okay, why don't we stick with 0.35 and make everything the same? So I'm going to go ahead and just grab this, bring it on down to its edge, and raise this up. But I want to make sure I'm grabbing everything here. So let me isolate this and actually grab the face. Yeah, you know what? It doesn't go all the way around. So we're set there. Probably grab all this stuff. So let me go over to vertice mode. Let's grab all the stuff here. Okay. And now we can go ahead and adjust. I'm actually going to bring this pivot over so I can use it right next to it here. Might as well just bring these up too. It's not necessary. There's nothing really influencing that, but we can just bring those up as well just so it has a little bit cleaner geometry. Nothing too important. And there you have it, 0.35 there. That should give ample amount of space. I'm just going to undo and redo, see what happened here. Make sure I'm doing everything correctly. Yep. All right, that should give all the room we need. And how deep is this going? Is that where it needs to be? Yeah, I think so. So that's looking really good. Again, we don't need the lid. We're going to copy that and bring it over to the other scene, pasting that in. There it is. And again, this is going to have the pasted prefix. So I'm going to go to search and replace names, replace that. Let's see if anything else has anything like that. Nope. So over here we have model, panel, to view, selected, set. That happens because these isolations are selected in different views, and I'm just going to go ahead and start cleaning up the scene here so we can get it ready for printing. Take these out of the groups and delete them. So we have some funky geometry over here. I don't really like the way that's looking. All right, I'll go ahead and delete that, and possibly even that one, as well as that one and that one. And none of this really matters on the outside, but I just want to make sure it prints cleanly for our test here. All right, so we have, let me put this in a layer as well, actually. This will be tolerance test number 4. All right, so we have all of our objects here. We don't need the full leg showing there. We have the drawer, the part of the bottom of the Stealth TV tray. We have the connecting points and this connecting point. And that's all we're going to need to do. We're going to grab these. We're going to go over to select, use constraint, next selection, face mode. And we're going to want to click end-sided. Make sure all the end-sided polygons, the n-gons, are triangulated for the slicer software to be able to read it. Close and reset. Grab, automatic for the UVs. Modify freeze transformations, edit, delete by type history. And now we're ready to take this into Bamboo Studio. So I'm going to export these out as OBJs and I'll see you there. All right, guys, so we're back here in Bamboo Studio and I'm going to bring this piece in. I'm going to go 90 there, 90 here. How about negative 90? Very nice. And let's just bring that over. And that's looking good to go. I'm going to slice that and I'll see you out in the real world. All right, guys, so we got the SD cards loaded up and they're pretty much ready to go. I'm gonna make sure my filament is where it needs to be. PETG, correct. Let's see the files. I don't like that that doesn't show. So I'm gonna go ahead and reset it. And how about this? Let's see about the filament. It's at PETG, wonderful. And the connecting tolerances are there. So we're gonna go ahead and get that started. I always name my files with the time it's going to take. So I name whatever it is, __, hour and 54 minutes. Just helps me keep track of how long things are going to take. So let's go ahead and print that out. We do have the blue PETG up there. Wonderful. Over here, it's the white PETG. And let's just make sure that the file is showing. It doesn't show. I guess it doesn't matter. But we know that the PETG's loaded up. Let's print that out. All right, guys, so these just finished up literally just now. But I realized that this piece here is not the correct piece. I think it was the old version of this, and so after I had extruded this part or got this part added to this part, I didn't replace it with the right file. So I'm going to go ahead and print the other side that fits into this now, and I'll see you when that and that are complete. This is almost complete too, but still has a little bit of time. Alright guys, so both of these finished up. There's one piece. All right. By the way, it's been kind of hard to clean off. I don't know what the deal is with that. But nonetheless, we also have this one here. And let's see how easy this one... Yeah, that one comes off real easy. I love that. I really love how that comes off. But now, we are ready to do the real test. So let me get the pieces needed for that. So we got this piece here. It's already cleaned out, ready to go. And we have this piece here, which I want to clean these supports out first. Yep, there you have it. Okay, so here's the moment of truth. Oh, perfect. Very nice. That worked great. I could even pull it out if I want to. That, I feel, is perfect. So this piece, just as a recap, is where these two parts connect. So this is basically this side, and this is this side, and they connect perfectly. All right. Very nice. Obviously, this one's going to take a little bit longer because there are a considerable amount of tree supports in there. So we'll do that last. Here is that center bar, and it's tight. So if I stick that through, it's going in and it's getting stuck, and I can actually pull it through. So that's exactly how I wanted this part. And last, but definitely not least, is this connection point to the bottom bars. All right, that's great. Doesn't even come out. Yeah, I like that. This one will probably require a little bit of glue, but really perfect. I can make it even tighter, but I think I'll leave it and just glue it together, or maybe drill a hole. I don't know yet. I'm trying to make this all 3D printed, so maybe I can make it just a tad bit deeper and make this longer so that they can kind of get stuck onto each other. And that way, I don't have to use any sort of glue. And that's the main goal in the end anyway. That's great. All right, so cleaning this off, it's a little bit of a hassle. So I think I'm gonna do it off camera. All right, guys, so after a lot of cleaning, that took about 20 minutes, and that's just too much effort. Maybe not 20 minutes, maybe 10 minutes, but that was just way too much effort and way too difficult to clean out those tree supports in there. But let's see how it functions. Yeah, that is smooth, and it doesn't really come out. I thought I'd have to put some sort of latching mechanism in there so that it doesn't come out, but it doesn't. So that's very good. It does come out when you pull it, and it's exactly what we wanted. That looks really nice though, I have to admit. And it looks like it did crack right there. So hopefully that's not gonna mess with the results too much. But if I were to hold that down, and yeah, it still works. So that is honestly very smooth, and I can see that working as the compartment area. But I'm wondering if maybe I should come up with something where it can open like this, or maybe like that, so it wouldn't be like so difficult to clean. I gotta think about it. But nonetheless, everything we've tried now is a success. Only part that I'm not too happy with is cleaning out the tree supports here, and I'm wondering if regular supports would have been easier to clean. But this feels so satisfying, and it's so perfect, and it doesn't even open up. No matter how much I go like this and try to get it open. It did a little bit, but when it's horizontal, it's gonna stay shut. I don't know yet. What do you guys think? Do you guys think I should try to figure out a method where there wouldn't need to be any supports like that in such a tight spot, trying to clear it out? Maybe just have like a door type of lid where you can just like open it like this, put your stuff in, and close it. I think I'm kind of steering towards that, but I wonder what you guys think. At the end of the day, this Stealth TV tray is going to be put on my Maker World for free, download, and if you guys want to make it too, when it's on there, keep in mind what you would like. Would you guys want to have to clean out supports like that? And there's no real no stopper here. It just kind of stops on its own, which is pretty cool, but also has a chance of the lid opening up and falling out. So yeah, let me know what you guys think about that. Would love to know. All right, guys, so we're here in Maya, and I got a few files open here. One is the completed desk from the previous version, so that we can add everything as we go along. So this is the previously completed version, and since then we've done a bunch of tolerance tests and whatnot, and we're just gonna update everything so that it matches now. And I will say that, again, we're just going to get rid of the stuff we don't really need. That worked out pretty good. And we're just going to keep the stuff that needs to be updated. So this needs to be updated, but we'll keep that as kind of a visual representation. These dovetails worked really well. That also worked really well. So let's see what we've got in B. We don't need B. And if you've been following along in this series, you would know what all these things are. We already have an updated version of that. So we can go ahead and grab these, and I realize we have an updated version of that as well. So we're gonna grab those, take them out of the layers. We definitely don't need them there. And we can come into this scene here, which is the last scene we worked on. I'm just gonna bring those up. And we'll go ahead and make it correct. I know that since the last scene, we've definitely updated a few things. So first thing I want to work on is get the simple stuff out of the way. So I'm going to grab all this, just throw it in a layer. And I know that this is the hole that I've worked on. So I'm going to duplicate that. That's the screw hole I made bigger. And I'm just going to grab everything here except the cylinder and delete it. We don't need anything else. I'm going to delete that as well as that. And now we have what we need. Now I have the center there, and I could just vertex snap that here and match the whole size. Going to grab all those verts there and into size to match. That looks perfect because you can't even see that. So that's how I know we've reached the screw hole size we need to reach. Likewise, we want to make those screw holes big as well. I like this star pattern it made. That's really cool. And I'm just going to scale to match. That's looking great. And I'm going to do the same for this one here. As a matter of fact, would I want the screw cap to be big? No, because it needs to stay snug on there. So I'll just make it a tad bit bigger just so it sits in easily. But other than that, these I can officially call complete. So all we're going to need from this is pretty much that. Oh, I'm glad I saw this because I do need to get rid of this inner part. Here's the old one. I'm going to go ahead and go to contiguous edges, detach. All right, and so now that's detached, goes all the way in. I can extract the faces, so it's two separate objects now. Very nice. And now we can bring back everything we're working with. We have this piece, we have the smaller piece we actually need, and I want to border those edges again so I can just make sure that everything connected. I kind of want to make this the last version I work on, but we may never know. Prototyping process, you could always find something later on down the line and need to adjust, but this is complete, so we can throw that in the completed section. Is there anything else in here we can work on? Yes. So we have this the way it needs to be, but I do want to create a simple locking mechanism. And how I intend on doing that is just kind of at the very end here, creating like a little speed bump and then having the negative speed bump cut out of the lid so that when it comes there, it kind of latches into place. Even though this actually works really well, the lid, I just want to make sure that it's staying put, you know. But we'll do that in the main file. So with that in mind, I think we're ready to move on over to the main file. I'm going to bring these over. And I do want to make it a different color just so I know that, hey, these are the ones that I brought over. I think we're ready to copy and paste them over. Copy and paste. Cool. And as you can see, we got some pasted prefixes here. We don't want that. We just go to modify, search and replace name. And we could go search for pasted underscore underscore, replace with this $ all, and that gets rid of everything. Okay, so the first thing I want to work on is this drawer. I'm going to bring that out and let's take a look at this table. And the first thing I'm going to do is increase the size here. This blue is a little hard for me to work with. I do want to make it brighter so I can just see what I'm doing better. So with that in mind, I got all this stuff. I'm gonna vertex snap it at a certain point so that when I bring it over here, I know that I've lined it up properly. As you can see, that's lined up perfectly. And now we just need to make this hole bigger. And to do that, I'm just gonna grab all these verts, and now I can make the hole bigger. All right, so let's go ahead and match that. And like last time, I'm just gonna bring this over and increase the size here, there. All right, there you have it. I feel comfortable deleting this one and calling this part complete. However, again, I do want to make that speed bump over here, and I also want to do the same thing for the lid, the negative version rather. And let's see, since we've got a lot of triangles here, hopefully it won't give us too much of an issue trying to create something simple like that. But I think I'm gonna make it easier for myself and just kind of boolean it in. So I know that I want this little bump to be really small. And when I say small, I'm talking 1 millimeter. So I'm going to go ahead, grab a measuring cube, multiply that by 10, and this should be at 1 millimeter because we should be in millimeters, but I'm going to double check here. Yep, we're in millimeters. And we're just going to zoom in on this guy, bring the pivot down below, and raise it on up. That 1 millimeter looks like a lot. Why don't we do 0.5 millimeter? I think that, I feel like, would be better for me, at least, because that looks like quite a distance. Let's grab this, 0.5. There you go. That I feel like is a better height for a little bump I'm going to be putting in here. I'm going to grab a little cylinder. Let's actually bring it over here and rotate that. Very nice. And bigger. Sink that in. And I actually like sinking that in at a halfway point. And maybe we can elongate this. That as well as elongate it this way. Matter of fact, we can grab that, snap it over to that edge. Maybe just let it sink in just a little bit. And this one, we don't need to let it sink in. Yeah, maybe just this way. All right. Now that's looking good. Now I'm just gonna duplicate that, bring it on over to the other side. I kid you not, guys, this was kind of bugging me. I really wanted to put in this little locking mechanism so that it doesn't create a problem later on. And I kind of just lined it up here like that. This is looking good. So we got our little bumps in there that I feel like would latch on pretty well. Maybe we can bring them out a little bit further, about here. Yeah, that's looking good. Now I want to grab my lid and bring it on back, but I do want to isolate those cylinders I just created. So let's take a look at what we're working with here. So I'm going to grab these, duplicate them. Now that we got a duplicate of that, I can grab this and bring it back and work on that. All right, so now that we're here, we can go ahead and work on this a bit. And I'm just now realizing that the way this sits in here, maybe I can raise it up a little higher because it's just so low. And so I just want to make this a little bit thinner so as it passes over this, it's able to pass over easily just in case. As a matter of fact, I'll bring it out about this much. And then we'll just grab all these faces here and delete them. And now we can just go ahead and raise this up by extruding it, making it match up to there. Make sure these are connected. And now we can go ahead and start bridging. Fill that hole. And there you have it. I'm just going to make sure everything is connected. All right, now we can go ahead and do a Boolean. We'll do a difference function. All right, that's looking good. We have that little lock piece that I like. But I just realized something, that we do want this to be a little bit bigger so there's a little bit of a tolerance. Totally forgot about that. So I'm going to go ahead and duplicate that. I'm going to bring this on over to where I think it'll connect and increase the size a little bit. But let's bring this back to the center and increase the size. All right, and bring it on up this way. Match it. Very nice. Now I feel like I can do that Boolean difference. Perfect. All right, so that when this thing goes in, it'll just lock into place with those there. I'm going to go ahead and delete the history. Likewise, I want to do the same thing for this side. Rest down here anyway. Yeah, that actually would work great. So with that in mind, I can bring this back out and we can just go ahead and run a Boolean on it. And with that there, I feel confident that we have a functioning locking mechanism. All right, so I have to line up the legs where they belong. So I want to go to a place where it's kind of easy to line it up with. And I think the best way is probably right here. Let's line that up there and just rotate it until it's correct. Now I can go ahead and delete that leg. That's in its place. Now we're going to do the same for this leg. That's looking good. Everything is lined up perfectly. Now what I'll do is I'll just grab these, put them in a group and duplicate special them over. They got to be in the right orientation. And there you go. I'm just going to throw those in a layer for right now and delete these legs. Sure, they were deleted properly. Okay, we're almost there. All we've got left to do is place everything where it needs to. And what I mean by that is just the washer and this nut. And I can say, guys, that we are ready to print this thing out. There's just a couple of things we need to do to make sure everything is clean. And I'm going to go ahead and do all that off camera. Basically, I'm going to clean up my scene, delete all extra groups, and make sure everything is UV'd, triangulated. There are no n-gons, and we can bring it over to Bamboo Studio. All right, guys, so we pretty much got everything labeled out and it's ready to go. So I'm going to see you guys in Bamboo Studio after I export everything out as an OBJ. Let's bring this in. We're going to make it 90 degrees, laid down flat, and it's just like how we planned it out. It's almost the entire plate, just minus maybe a couple of millimeters. And as I've mentioned before, I'm not going to make this too dense. I usually put the strength at 4 wall loops with 60% infill and gyroid. In fact, the only thing I'm going to change is I'm going to change this to triangles or maybe honeycomb. I think I will go with triangles. I haven't done triangles in a long time. Someone had suggested doing triangles in the comments, so I'm going to do it again and do it for this model here. And this thing's going to be pretty solid, so I'm not assuming we will need any sort of extra strength here. So with that being said, let's go ahead and just slice it. All right, so it's going to take 11 hours and 9 minutes and use a total of 324 grams of filament. Not bad at all. I'm just going to export this out and we'll move on to the next one. All right, so let's go ahead and just grab this, delete it. For those of you who are new to the channel, I can show you my supports that I use because it's a little bit adjusted, not too much, but I feel like it gives me a good time with removing the tree supports. So here's this section, and I'm going to scroll on down so you can see this section, and there you go. And likewise, I'm just going to leave the strength of these tabletops the way it is. I'm just going to rotate it on down 90 degrees and give it a slice. All right, guys, so let's move on to the outer leg. This is the right-hand side of the top part of the leg. We're going to have to rotate that in Y, and we can just rotate it by hand this way so that it takes up the entire build plate. And for these parts, I do want to make it as strong as I can, so I'm just going to go ahead and do a 60% infill with gyroid and do a number of walls of 4. And I only have 5 printers here, and I want to print out as many things as I possibly can. So I know I can't do another leg, so maybe let's try importing in other objects that we may be able to print, like this. And let's just load up the build plate. I'm going to rotate this as well in X. And I already know that I want to rotate this in Y. Let's do -90. We've done all the tests here to make sure these are all strong. Let's see if we could get this cylindrical bar printed out, if it's not too long. And I'm going to rotate that in Z 90 degrees, or how about 45? There you have it. It's really close, but I feel like it will do the job. How about this center bar? Maybe we're pushing it, maybe not. That's actually looking really nice. Let's do -90 in X and -90 in Y, or was it just 90? Yeah, it was just 90. And let's see if I could fit it on this side here. It looks like I can. All right, how about these smaller bars here? This is already laying down flat the way we want it. I'm going to rotate this in 90 and bring it on over. And let's bring in that other bar, and we're going to rotate this, what, 180? Yep, 180 and 90 here. And let's just bring that on over this way. Very nice. I feel like I'm going to be able to do a lot of prints on this one print bed. So we've got all the dowels, and they're exactly the same. So once I have this positioned the way I want it to be positioned, I think we'll be able to just clone it. And I just clicked this here, by the way. It's auto orient. Sometimes it works, sometimes it doesn't. This time it seemed to have worked. Okay, now we just right click, clone, and we can do number of copies as 3. There you have it. Now obviously we don't want these to intersect with each other, and bring it on up. That should work perfectly. All right, next we have a center bar, which that is pretty large, so we're not going to be able to put that in there. How about we try to fit all the screws on this one? So we have 1 screw there, another screw, another one, and looks like we have 3 more. So we have 6 screws, and I'm just going to go ahead and orient them using auto orient. Very nice. Back in the day, you'd have to worry about doing too many things on one printer because the print quality wouldn't come out as good. And although that still might be the case a little bit, definitely not as much as before. So I'm really pushing the limits here on this Bamboo Lab A1, printing out all sorts of different objects on one build plate. And let's see if it can handle it. I'm actually really curious. All right, we got some screw caps that are up next. And the last one, there you have it. Very nice. We don't have that many models left that we're going to be able to put onto here. So I feel comfortable just saving this out, slicing it first actually. I wanted to remind you that I'm just using generic PETG. All my settings are exactly the same for generic PETG, and strength and support were the only 2 updates I have made. It's going to work out. The only issue is it's going to take 24 hours, but that's all right. All right, so now we got a fresh scene, and we're going to upload the other files here. We'll do the outer leg bottom on the right side. All right, so we're just going to rotate this by eye. All right, and hopefully when we slice this, it doesn't go out of bound. Yep, that's looking great. All right, let's get that center bar in there. Hopefully this will fit. It's looking pretty hefty. I'm going to get it on the back side here. Although I do remember when we laid it flat, we got some strange patterns. So that was one of the tests we did actually. And I'm not going to lay it down flat. I'm just going to rotate this. And there you have it. All right, let's move on to the next one. Let's do the lid. And I feel like this can be printed solo like this. So let's just give it a slice. All right, so we got 6
legs left. So it looks like we're gonna have to print these out one by one. All right, folks, we have a total of 12 G-code files, and we're not gonna be able to print them out all in one night, but we're gonna use up all 5 and get this print started. I'll see you out in the real world. Unbeknownst to me, I had printed it out like this, so I don't want to blame the printer. It's actually user error where I had put it on this corner. So I'm just going to click auto orient. That was pretty much the issue. And do I dare just print it out again like this? Yes, I do dare. It was working out pretty good. And I can say that we don't need these washers because those washers finished up. You know what? While I was slicing, I said, let me come and check these screw caps, and they're actually perfectly fine. However, I did notice that the screws that I was printing out did have a layer shift. So I'm kind of worried if I print it out again, because there's so many things that obviously the quality suffers even on these Bamboo Lab printers. I'm going to print these little screws out separately so that they print out nice and straight. We need them to be really good, so I can delete those from that Bamboo Studio file. All right, so now that we're back in here, I can go ahead and delete these because we certainly don't need these anymore. And I want to print these out separately. So for that reason, I'm just going to take these out of this file and print them out separately. And I think we're good to go there. So let's give that a slice. And that's going to take 22 hours and 21 minutes with 400 grams of filament being used. And we are set. All right, guys, so I'm going to get this exported out and put on the SD card for printer number 5. And I'm going to get another print onto printer number 2, and I'll see you out in the real world. I am very happy to say that all of the 3D prints for the Stealth TV tray are pretty much finished. So I'm excited to say that we're gonna assemble it all today, and I don't mean to rhyme in any way. Before we get to building all that out, I do have a couple of videos from yesterday taking the table off the build plates, and I just want to show you how it came off and what the results were. And they were printed out down at the bottom there. And I do have to say that I took off the supports for the dovetails and those areas there. You'll see what that's about. There was no real answer to it, but yeah, you'll check it out in the video. I cleaned up all the support materials for this already, but I'll go over all that for the assembly, just in case you guys want to build this too. I'll see you back after that video. All right, guys, so the screws finished on here, and if I do say so myself, they are looking absolutely perfect. And that was the tall one, and here is the small one. Now I'm going to get the other print started. All right, guys, so we have both halves of the top part of the Stealth TV tray finished up, and we're going to take these out. I'm going to have to probably take it off with the build plate. There you go. That's looking real sweet. Wow, what a smooth, clean looking print. We got our little notches there. Really happy with this result. And that nice storage compartment too. That's looking fantastic. I'm just taking it out nice and easy. There you go. Very cool. Oh no, there's a part here that printed out very roughly. That is curious. I don't know why that happened. Doesn't seem to be anywhere on the build plate, but nonetheless, it's on the bottom. So I think I'm fine with that for now. But, you know, obviously we wouldn't like that to happen very often. We have areas where it's kind of thin, and I was expecting that. And there's areas where this meets up here that's also very thin. But nonetheless, this is looking great. Let me give this a test try. Oh yeah, guys, I'm really excited. And it's very light, but solid as well. If I were to bend it, ever so slight bends, but man, does that look sleek. We got the tree supports in the dovetail section, and I can't wait to put this together. Honestly, I'm so excited for this. Let's go ahead and take this one out now. All right, now this is ready to go. I'm gonna take the build plate off. That is also looking real good. This build plate's a little hotter to the point where it hurts my fingers a little bit. But let's see if we can get this off here. How's that looking? That is looking great. You can you can see the plate that I usually print out, the ghost image of it right there. That is actually really funny. But I could always use the flip side of this build plate. But man, that is looking so clean. I cannot wait to put this thing together. I'm gonna hold myself back until we have all the parts that are ready. And just to kind of give you a glimpse
Man, that's gonna be sweet. I cannot wait. All right, guys, I'm gonna get these build plates cleaned up and start the next print. As you can tell, this black filament from that same company I get it from is producing that beautiful result that I get with the gray filament for the plates and latches. And by the way, for those of you who are new to this channel, this is my tiny 3D print farm of 5 Bambu Lab A1 3D printers that I use for production of plates and latches. So here's the left latch, right latch. Let me see if I can pull one out. They look really, really nice. That's the right latch, left plate, right plate, and these attach to a larger product that I don't really talk about because it's not 3D printed and this channel is focused on 3D printing. And for the Bambu Lab A1 with AMS Light combo, I use near empty spools of filament, ones that couldn't finish an entire latch or plate on their own, and they get so low where they can't do it on their own, and I end up bringing it over here and activate the auto refill system by putting in the software that all 4 of these slots are PETG and gray, and so when one finishes out during the middle of a print, it'll just switch over to the next spool and finish off the print, which is absolutely wonderful. I do have 3 Creality printers. I have the CR6 Max over here, I have an Ender 3 V2 Neo down there, and a Creality CR10 Smart right here. And those were good for a time, and I used to actually use CR10 SEs for my production here of these parts for a short period of time, maybe a month or 2, and then I realized that I didn't want to babysit them anymore, and so I pulled the trigger. I think 3 days before the sale ended for these guys, there was a big Bambu Lab sale going on, and I bought them, and it was probably the best decision I've ever made in this 3D print room for production of these parts. But nonetheless, we have a bunch of 3D prints here that are available for my Make World for free. We got Lightyear laser blade, all these cool little prints. You can go ahead and check them out. It's linked in the description. And this is a Stealth French side table, and it's in the same sort of style, the geometric stealth style, that the Stealth TV tray also has. So you can say they're in the same line. By the way, the temperature in the 3D print room is 80.1 degrees Fahrenheit, and there's a 51% humidity level in here. Yesterday, I should tell you that it did actually reach 102 degrees in this room. And here in Southern California, it's actually going to reach 111 today. At least that's what's reported online for the weather. And I honestly thought I was looking at a mistake or something. When I saw that it was 111, I had to do a double take. Really, 111 degrees here in Southern California is unheard of. But I'm glad I'm here in the morning where it's a lot cooler. We could put together this awesome Stealth side table. And before it gets too hot, let's get this cool Stealth TV tray built out. Very cool. By the way, I did want to mention that this is going to go on my Maker World for free download, so you guys can join along. And if you guys are interested, this has been a long series, so I'm gonna do a compilation video and put all these Stealth TV tray videos together as one. So there will be a longer format where you can just watch the entire process from beginning to end. But nonetheless, let's jump into this. I had to make me a nice strong cup of coffee this morning, but it's nice. Alright guys, first things first is I'm gonna take these off. See how easily they come off the build plates. That was fairly easy, very nice. All right, as well as that one, very cool. And likewise, we got these here. Yeah, that came out real nice. Okay, and last but definitely not least, the lid. All right, and we do have our little notch there for that little locking mechanism, that speed bump we made. This is gonna be sweet. And all right guys, let's not forget the main build plate here. Very cool. Oh my gosh. If you guys could feel how this feels, it's just so nice. I know I say that a lot, but I really love PETG filament, especially after working with Bambu Lab A1 printers. They really just made printing with PETG so much easier, and it really just looks so nice. Super cool. All right, here's the leg that we have for this one. Printed out great, very nice. And here's that center bar that didn't print out last time. Printed out great this time. Very cool. I say center bar, but the under table hexagonal bar. Here's the center bar. Let me actually loosen it up like this. These are all the dowels, by the way. There's 3, and then the 4th one's right there. And We have the under table bars. Wonderful. This one's gonna take a little bit of cleanup, but should be pretty easy. Cool. All right, guys, so I don't know what happened. I had pressed record, but something happened. But I took off the supports off of here. It was real easy. We're just going through and cleaning up all the support material and putting aside whatever is already ready. So I could say those are ready. This is ready. These are also ready. I'm just gonna put them over here. And all that's left are these leg pieces to clean out the support material in there for the dowel. Oh, by the way, here's that center bar down below. And most of these are not clean. There you go. So yeah, we're just gonna have to do some work on cleaning up the legs here. And I just finished doing this one, so we'll move on to the other ones. A little bit of a tree support. All the legs are gonna have that tree support on the inside because of that dowel. And I'm just going in with the flathead screwdriver, and I'm pushing it in and kind of breaking off those tree supports now for the top. All right, there you go. Some of that came out pretty easy. And let's see if there's anything left inside. Yep, there seems to be some left inside. And I'm just kind of going in and pulling out like that. And it seems to be working. All right, that about does it for the tree supports in here. I just kind of put it at an angle where I can see light shine in there and I can make out that there's no more supports in there. So I just take out that front piece once again, and sometimes the top is loosened up like that. I don't know if you guys can see it clearly, but the top part of the tree supports is loosened up. Wow, all that came out. Very nice. That was actually the easiest one. Let's see if we can make it. Let's see if we could just come up with a way of doing it so that it's pretty easy. And again, this top part comes out pretty well. I noticed with these tree supports that they end up having this top little flat part. This was for this piece here. So if you can manage to get your flathead up top there, it comes out pretty easy, like you see here. All right, that cleaned out as well. And since you guys kind of got the hang of it, I think I'm just going to do this off camera, but some of them have this support down at the bottom, and it usually comes off pretty easy. And let's see if I can just take it off with maybe some snippers, because that one came off easy, but yeah, it comes off fairly simple. And like I said, it has that little flat part there, so that really helps take it off. All right, guys, so we got all those legs finished up. Now comes the most difficult part. This is cleaned up as well, so we could put this aside. But the most difficult part is cleaning up these tree supports that are in here. As you can tell, there's a lot of them. However, as I've mentioned, if you could somehow get that top layer to come off first or loosen it up a bit, it really helps. And maybe even breaking these tree supports first as well. But I'm going to give it a try here and kind of give you the best method of cleaning those out. And they're on both sides. So I'm going to set up a soft base over here with this bubble wrap, because I am going to try to get at it with a hammer a little bit. Let's see if this method will work. So I'm kind of holding it up against me there, and I don't want to be so harsh with it where it makes this piece bend up. So I got to be very careful. Now I was using this in the past, so I'm going to give this a try again. So I'm kind of going in at the bottom there, if you guys can see that, and I'm just pushing forward, and see how that's raising up. We want to be very careful not to do that too far down the line. And there is no break there like last time, so that's good. I'm going to go in and try to pull some of this out with my needle nose pliers here. See how that top part comes out? That's what we like to see. You got the tree supports on the bottom with that top part there. All right, this has probably been the best tool for me. I'm going to try to go up top there, but remember to be very careful with that so it doesn't bend too much. I think we're doing it, guys. Now with that, let's see if I can just use these to pull them out to the left. As you see, it's coming out. After about a few tries at this, I think I got a little better at it. How about with this small little flathead? Didn't have enough leverage there. How about this bigger flathead? All right, got a little bit more out there. Yeah, I think this is working. So with the flathead, we can just kind of push up and pull this way, and it comes out a little bit at a time, but nonetheless it comes out. And I feel like it's the safest way. that I've done it so far. I feel like this thing wants to come out all in one go, but we'll take it easy and go slow. I already kind of nicked myself earlier. I think I was using these needle nose just maybe like a minute ago. And it's kind of important that we see that top part come out and not just the tree supports, because we want to make sure the tolerance is accommodating for that lid. But we're actually making the fastest progress I've ever made with this here. There you go. I got filament flying everywhere, guys. So make sure you do this in an area where you don't want filament flying, especially if you got an open cup of coffee nearby, which I safely put mine in a different room. Alright guys, we got one side completely cleared out. That's looking totally good. Very nice. And I think you got the gist of it. So I'm going to go ahead and just do the other side off camera, and I'll see you when I finish up with that. And I did want to mention that there might be some strings here or whatnot, so I just went in like this and kind of straightened that out. And I don't know if you guys can see it, but our little speed bump is right there at the corner of my blade. Very nice. Alright guys, so I finally got this cleaned out, and it is slow going, so just keep that in mind. It's definitely a slow going process. And I think we're ready to give that lid a try. Alright, let's do this. Yep, that's in there, and that ain't going nowhere. And it's definitely locked into place. Let's see how hard this is going to be to take out. There you have it. Now, if we want to make this easier so that it's not such a hard time taking in and out, which I can see that this will get stuck over time, and it seems to have gotten stuck here, and I kind of scraped it there, but let's see if I can just turn these like that. Yeah, so one way to fix that, sand these sides down a little bit so it's not sticky. I know there's a little bit of stickiness to this. For example, with our test, we did sand it down a bit, and it did make it smoother, and this will go in just fine. As a matter of fact, we may not even need that little notch, but it's there, and because that speed bump there does its job. And as you can tell, when it's sanded down, it holds up perfectly. So I think I am going to sand this just a little bit so it's a little easier. It goes in and out just fine, but when these rub enough, it's going to be kind of hard to open up and close. But honestly, now that I'm doing it over and over again, the technique to open this is use both of your thumbs to kind of push from the front and the back, and it opens. With that being said, I think I'll leave it. I won't sand it. So I'm just going to pop this back in. Very nice. Wow. I thought I'd need to do some more work on that, but this is looking real slick. Now we're ready to put these two table pieces together. One of the most exciting parts for me is this part. So we got our dovetails, and by the way, this is going to have a little bit of a support material as well as here and here. You're going to have to take that out. Should be very easy. Likewise with this part, that part, and that part. And there will be some tree supports in each of these holes. So I'm going to go ahead and put this thing together. Let's line it up. And the goal with this is that we don't have to use any sort of glue. And it's nearly there, as you guys can see, with just pushing it with my fingers. We are almost there, guys. Let's see if I can kind of make it go in even more with this hammer. Ever so slightly. We're nearly there. So close. Just ever so slightly off. Okay. Notice how I have this bubble wrap here. And I just want to say to be very gentle when hammering that in. Everything is looking pretty sweet. There's just a little bit of a step there. So I'm going to try to work it a little bit more, because I do feel that these ends here, they're not fully in. Alright guys, so I think I got it as close as I'm going to get it. And that's looking good to me. Very cool. There's a little bit of a gap there, but it's going to be sealed up. Wow, this is coming together, guys. So I think the next part we can do is put these on, which go just like that, the long and the short part. So the hole is on the side of the tablet slot holder. we're just gonna have to glue this in. All right, guys, so I thought I had some epoxy adhesive on hand, but I don't. So I'm gonna make a quick run to the store and pick some up so we can finish this Stealth TV tray. All right, guys, so I'm back from Harbor Freight, and I got this for $3.49. That's without tax and all that, but it's great. It's an instant setting epoxy adhesive, sets in 90 seconds, holds up to 2,000 pounds per square inch. It does metal, glass, ceramic, plastic, rubber, and wood. So, I obviously got my protective gear on. This stuff says to take off the cap, mix it, and get it ready to apply. And then when you're done, to put back the cap. So it sets in 90 seconds and the item could be handled within 30 minutes. So let's get this show on the road. So here's that little tip that they're talking about. Now that we have this ready to go, I'm gonna just bring this over to the side and have it ready to place. Now I'm just gonna mix it in right there. Actually, I almost forgot that we should probably make the parts that are sticking to each other not so smooth. So I'm just going to run this with 150 grit sandpaper until that shiny sheen is off of there and it exposes the material. And again, I only need to do this a little bit, not too much, and I'm happy with that amount there. I'm going to do the same for all of them just to make sure they have a really strong bond. Alright, I'm happy with that. Now I'm just going to do a tad bit on the inside here, just enough to expose some of that PETG surface there. I'm happy with that. I could already see that it's changing color. It's getting more of a matte finish rather. And finally we'll just do this last part here. That is looking good. Now once we have this set in, we do need to have some things that sit on it and weigh it down. And for that, I'm just going to use a couple of filament boxes. And they do have filament inside, just to just to clarify. But let's get this epoxy cap off of here. I'm glad I wore gloves. And we're just going to get this mixed up here. All right. And I'm just going in with a piece of filament, PETG. You could use wood, but I had some extra filament laying around, little dowels, just using that to spread it around. And time to get this in place. Alright, that's set in place. I'm going to do the same for this side. I might have put too much on this side here. Let's see if it leaks through. I think that's fine. Likewise, let's do the same for this. Alright, now this is ready to go. Very nice. And last but not least, I'm going to squeeze some in here. Okay, and as you can see, I'm just kind of mixing these up. Alright, I think this is ready to go. I'm really glad I made these connecting points so I know exactly where to put it. Now I got some of that fresh filament. Just gonna pop it on. Let's see if I could just put it like that. There you have it. Very nice. So I'm gonna let this set for a little bit, and once it's done, we'll come back and continue the rest. Oh, and by the way, the cap for it's right there. And there's a little notched end here, and there's a little slit for that notched end, and you just cover it like that. There you go. Very nice. Alright guys, so I just happened to notice that we didn't clean off some of these supports, so we're going to do that now. And also, I'm missing one of these legs, so there should be one more of these. So I'm printing that out on the printer behind us on printer number 2, and in the meantime, we can kind of put the rest of it together. So I'm going to first clean off these supports. So you see there's this part for the center part to fit in, and we have another one here. Or was it this one? It was actually this one. So it is kind of hard to see in the beginning, so just make sure you choose the right one. And there you go, came right out. Very nice. And likewise, we have this part for the hexagonal bar. Very nice. And this one as well. Boy, this one is almost non-existent, or it doesn't look visible, but it's there. All right, there you have it. So these are officially ready to be put together. Let's give the hexagonal bar a try. Oh yeah, that fits perfectly, and it comes in and out as needed. If we need to, we can always do an epoxy on this as well, epoxy adhesive, so it sticks really well. But we'll see if we need to do that a little later. In the meantime, we're going to put together our legs using these dowels. And as you remember, I put a little marker there for where each dowel stops. Now there's a longer side and a shorter side, and the longer side is actually going to be pointing up and the shorter side is down. So we're going to actually grab the top bar, and that's the depth that's going to go into the top bar. And like we did before, we're going to gently use a hammer to get this dowel in. And I'm going to know it's fully in once it reaches that line. Alright, we just about reached it, if you can tell there. I feel like it's reached it all the way through. And now, I know that these legs with the hole for the hexagonal bar require the hole down here. So, I'm just going to go ahead and stick that through now. And likewise, we're just going to stick it in and push it through. Wow, that actually worked really well. We have a little bit of a gap, so I'm going to try to use a hammer up top here to kind of close in that hole. So not only did I use the hammer, but I kind of banged this part up against the floor like that, and it seems like that's as far as it's wanting to go, and I'd say that leg is done. Alright guys, so likewise we're going to do the same with the other legs. However, we're going to do the other side now that doesn't have the hexagonal hole and that center bar hole there. We're just going to grab another dowel that we've 3D printed. And remember, the long side goes up. Now we're just going to again hit it until we reach that line there. It seems like this dowel is just a tad bit too long. I might have to update that in the model. And then we're just going to stick this through. Alright, I feel like that could just go in by hand. Alright, so it looks like I got it as far as I can. All of them are going to have a little bit of a gap like that. Seems like the dowel was just a little bit too long, ever so slightly, but that's okay. But the funny thing is we didn't have that issue before, but we're having it now, especially with the prototypes. We didn't have that issue, so don't know why this is happening this time around. Yeah, it looks like that's as far as that's going to go. I'm kind of curious to give a try of cutting these dowels down a little bit and see if maybe that was the issue. And I think I'm just going to test it out and see if that is the issue. So I'm going to grab these snippers here, cut off a little bit, and see if that will just fix the issue. So I cut off just as much as I saw that was kind of leaving a gap. And now let's stick the long end into the top. Yeah, that actually went right through, so this should close up just fine. Oh yeah, that closed up perfectly. Very nice. So it looks like you could just pop it out. It was pretty easy. Unfortunately, I could only cut the short end now, so I'm gonna go ahead and cut the short end. I do have to update the model now, but nonetheless, I'm glad we are doing this first prototype to see how everything fits together and works. Alright, I'm going to stick that through. Oh yeah, now they're touching. That's looking great. On the back, you can't even tell that it's two pieces. Guys, I'm glad I figured that out. So I went ahead and fixed all three there, and the gaps have closed nicely. We got 3 legs and 1/2 waiting for it to be printed out. But nonetheless, I can go ahead and adjust this dowel too now. Alright. That should work. And remember, we've got the long end that goes up top. Alright, we made it through. Very nice. So all we're waiting for now is just the bottom piece for this, and we can move on to the other parts. As you can tell, this goes here. I can't wait to put all this stuff together. It's gonna be so much fun. And this hexagonal bar goes right here. We're nearly there, guys. So until we have this finished up, we're pretty much on pause, but we're on a good roll here. I think this epoxy is done. Yes, there is a little bit of a leak into the edges, but I think that's fine. But nonetheless, we can't, again, do a whole lot until we finish this print here. But guys, I'll tell you what, this thing looks really cool. I wouldn't mind using this myself. We have that little storage compartment. How about this fatter pen? A couple of pins. Yeah, we could totally fit it in there. That's really cool. And how's about your phone? I'd imagine that would work perfectly. Alright guys, well nonetheless, I'll see you in a moment. For you, it'd just be a cut, and next thing you know, we're ready for the next part. But it's going to be about 6 hours from now for me. With that being said, I'll see you in the next scene. Alright guys, it is now 4:45 p.m. and it is 105 degrees Fahrenheit in the 3D printer room. It didn't quite reach 111, and it's 20% humidity in here. This tiny 3D print room is officially a filament dryer room. But nonetheless, this finished up, so let's continue the build. Oh, and this needs a lubrication. I don't blame it at 105 degrees, or 101.5 rather. I'm going to do that later. Just going to turn it off, give these guys a break, and get this stealth TV tray finished up. Looks great. Alright guys, much like the other legs, I just have to take out the tree supports, so I'm going to go ahead and quickly do that. Alright guys, so I got that emptied out, and I'm just going to pop this through. Just like that. Alright, we've got all of our 4 legs ready to go, and I'm ready to assemble this thing. We may have to do some epoxy adhesive to some other parts, but this heat and that time gave this a lot of time to really bond. So these bottom 4 parts are stuck on there very nicely. So first things first is we're going to grab this piece here and figure out which side this goes on. So you can tell because there's a straight side and a curved side, and likewise you can see over here there's a straight side and a curved side. So we just want to match that up. Very cool. Let me get the other side here. Got to move some of this stuff. Very cool. We got that in, and we may have to do epoxy to this. We'll see. And we got that part in. Okay, yeah, this is kind of wobbly, so I may have to do epoxy there. And before I stick any of this together with epoxy, I do want to just put it together and see where we're at with it all. I'm assuming it would be wise to put all the screws in and get everything sorted out that way. So we got our long screw here, a washer, and a screw cap. As a matter of fact, I do want to flip this around, and I'm working with very limited space here. So I want to try to flip this around carefully. I may have to just disassemble it. Yeah. The part that has this hexagonal bar are the inner legs, and the parts that don't have it are the outer legs. So just wanted to show you guys that. And we get a screw as well as a washer. Let's actually stick the screw and the washer in like that. Then we could stick it in onto the side over here. Very cool. And to my surprise, the screw is not poking its head out, which is very strange. In 3D file it did. That is very odd. So looks like we're gonna have to print out another screw. Alright guys, so we got this 2-part epoxy again. I'm just gonna start mixing it in here. I think that is more than enough. Alright, and I got a couple of mixing things here. I'm gonna use this one of these screws from the previous batch. There you go. And this seems really loose, so I do want to get epoxy on here. So let's get that nice and ready. All right, that's plenty there. And I'm just going to stick that in. Okay, that's looking good. I do want to add some epoxy to this right here to make sure it's securely in there. So let me just add a little bit here. I always say add a little bit. It turns out to be a lot more than a little bit. And let's give that a nice mix. And this stuff sets uber fast. So let me dip this side in. Let me dip this side in. And pop that in there. Very nice. Now I feel comfortable that both of these have epoxy in them and they're going to be holding up very well. But nonetheless, we got to jump in the computer, fix those screws, get them printed out, and I'll see you in the computer. Alright guys, so I jumped into Maya and Bamboo Studio, and there were several things wrong with the screws, and I didn't really catch that. One of the issues was, and we found that out because of having printed it out and trying to use it, was the screws were too short. So I lengthened these screws significantly, as well as the screw caps, so they have a lot of room to sit in, and that way I won't have to go through what I just went through. And these were actually too long. They were about this much too long, so from here all the way up to here. So I fixed that, and we're just gonna throw this on the SD card for the A1 and get this printed out, and let's finish up that Stealth TV tray. Alright guys, it is 7:25 p.m. and these are finally ready. By the way, it is still 108 degrees Fahrenheit with 19% humidity in the 3D printer room. I kid you not, guys, it is hot. But nonetheless, I'm gonna take these off and let's finish off that Stealth tray. All right, guys, let's get this Stealth TV tray wrapped up today. These holes should be lined up. We're gonna stick a screw in through there. We're gonna put a washer, then through this here. And something I didn't take into account when making the screws extra long is it's going to be hitting, but nonetheless, let's see where this takes us. Alright guys, so if I'm not mistaken, this is how we have to have it set up. This fancy part goes on this way, while the slot is on the front here. So that's how it should be set up. And we're going to go ahead now and give this a try. And we're going to fill these up with epoxy now, because we want it to be really strong. Boy, this thing's already setting. This is quick. So I'm going to get some on this tip here and just pop some in there. Okay, and stick that on. That should have set by now. There you have it. I'm just going to hold that for a second. And we're going to have the makings of a Stealth TV tray. And I think that this is probably going to be a first prototype until we get that final design ready. Well guys, I must say, this is looking real sweet. We're still waiting for the epoxy to fully dry, but it is seriously coming along. And I have one more thing I need to put in, which are these here, but I still am waiting for these to continue to set. And until that's had a little bit of time to kind of settle in, I'm gonna wait to put those on. All right guys, here's a side-by-side comparison of the Stealth TV tray versus a regular wooden TV tray. And that is looking real cool. As you can tell, we got a little bit of a short distance from there to there, but the width is the same, and also the height. Seems like the Stealth TV tray is just a slight bit higher, and Stealth TV tray also has a real cool drawer. Not only that, you got a place for your phone to hang out, to just watch, and maybe your iPad. I honestly would love this in wood, but I don't know how well it'll hold up. I'm wondering how much weight this will be able to carry. Maybe your hand to write on, but boy oh boy, it's wobbly. Well, this one's wobbly too, so I guess that's fair. What do you guys think? Do you think that this would be able to be CNC'd with corners like this? Or not corners, but like this kind of design? Would a CNC machine be able to do that? And as a matter of fact, I went with this kind of drawer style because I saw that CNC machine can do something like this. So I wanted it available to be able to be CNC'd if I ever wanted it to. The biggest issue is that there's no way to close this thing. Because of these screw caps, when it comes here, it gets stuck and I can't fold the legs. And as I was rotating it over, the screw broke, just like I suspected it would, and this is not holding. So would I recommend a fully 3D printed piece of furniture like this with moving parts, and instead of using screws, 3D printed screws? No. I kind of ran my test and I'm happy with saying that no, it's not something you want to do. By the way, if you take a look here, these are flat. That's one of the reasons why this thing can close and fold. But what's the final verdict? Definitely no. Do not 3D print. Do not 3D print a fully 3D printed piece of furniture. I'm kind of curious though, if maybe we could try metal screws and if it will still hold up. And if we do try metal screws and it does hold up, the next thing I'd like to try is a weight test. Try to fill up the table with as much weight as possible until the legs break. That would be an interesting test to run on this. But nonetheless, I've been sweating up a storm in this room at 98.4 degrees Fahrenheit. It is now 23% humidity. I can say that I ran that test and now I know, because I was always curious about that. But nonetheless, what if one day we do make a wooden version of that? That'd be pretty cool. Alright guys, it is the next day. It is September 6th, 2024. At 7:53 a.m. and I got it to work. There are a couple of things that I changed around, but first of all I do want to cover that I printed out a geometric pen cup. Well, I guess you could also call this Stealth because it has that geometric look, but I printed one out after yesterday's drop and just wanted to make sure everything was good with the number 5 Bamboo Lab A1 with the MS Light combo. And yeah, it is. It's looking great. It's printed out in PETG. And man, oh man. If you guys are interested, by the way, this is on my Maker World for free. And I got this thing to work. So what was the issue yesterday? One thing was that the screws did not hold up. So I ended up using machine screws and a nut to hold these in place. And likewise, the same thing happened to the bottom there. All the screws weren't holding up. So the answer is no 3D printed screws, but we're still on this journey. So I ended up using these machine screws. Now, to be able to make this thing close like this, to have it fold down like that, I had to screw it in the opposite way. So the Phillips head is right there and the nut comes out on this side so that there's enough room. Likewise, there's supposed to be a washer here and on the other side too, but I didn't put that in to make room for that. Now in the 3D model I could go in and fix it up and we could account for these things in 3D. And I would say that this is a successful prototype number 1. I also did use self-tapping wood screws for these parts here because it just wasn't gonna work again with the 3D printed screws. And it's working great. It's a little dirty from the floor, but oh, and there you go. I got a couple of pens in there, little card reader. Very nice. And by the way, I used these screws from Harbor Freight as the wood screws, and I used this one here. It's number 8 by 3.4 L, just so you guys know. I really like the gold accent on the black, by the way. And for the machine screws, I bought this from Harbor Freight a while back, and this is what we used for the rotary tool clamp. And I just used 4 of these long number 10 24 by 2 this here. I'm pretty sure it's going to require some Loctite so the screws, the bolts don't get loosened up. But you saw yesterday, compared to the regular TV tray, it's slightly taller. It's just as wide, just a little narrower. But the big question is, can this thing be used in a day-to-day life? And I'd say no way. I would not use this, period. For a prototype, I think it's great. Hence why FDM is known for rapid prototyping, because check it out. We were able to get this printed out in a day or two, and it works. Now, what do I want to do with this thing? I do want to do a weight test on it, meaning I'm going to put so much weight on top of it in a measured way until the legs break or something breaks. I want to know its capability for weight bearing. So what does this have the potential for? You can put your phone on there. This is a little makeshift phone. You can watch things as you, say, eat some food. Let's say you want some bigger entertainment. This is too small. Let's throw that over to the side and get your iPad on there. That's cool. You could just sit there, watch your iPad, have your phone, eat, drink your, let's call it lemonade. But not only that, you want to do some journaling. It's been a long, hard day like yesterday night. And you just want to get to some journaling, which I certainly did. At the very end of the day, it was about midnight, I journaled. You can certainly journal. You have enough room for this bigger size notebook. You certainly have room for this bigger size journal. You could just pop that on the side and open it up and begin journaling. But let's say you got homework and you got your big old laptop. It fits right on there. You can just get to typing on it. So this is all the potential uses for this thing. But before we can even see whether or not we could do something like that, we have to see how much weight it can bear. I'm gonna put as much weight as I can on it and record how much weight it can carry. But nonetheless, let's get this going. By the way, I almost forgot to weigh it out. I want to see what the total weight of this thing is compared to the other desk. I did take out the pens and whatnot out of there, so that's cleanly on there at a grand total of 4 pounds 8 ounces. Wow, that is pretty cool. 4 pounds 8 ounces. Let's take it off and do it one more time. Yep, pretty close. 4 pounds. Yep, 8 ounces. There you have it. Very cool. Let's see how heavy the wooden one is. All right, here's the wooden one. Let me try to do this with one hand. There you go. 6 pounds, 11.6 ounces. One more time. Yep, 6 pounds, 11.6 ounces. So you got something that's over 2 pounds lighter right there. So that's also convenient. But nonetheless, let's get that weight test going. I wish I had this for a longer period of time, but I could always print out another one. That's the great thing about 3D printing. All right, guys. So we're out here, and I got some weights here. I got 10 pounds, another 10 pounds, which equals 20. And we got 3 times 4. So that's 12. 12 plus 20, 32. So we got 32 pounds of weight over here that we're going to slowly put onto here. Now I'm going to try to do this in a controlled and balanced way. So I'm going to start out with 3 pounds just in the center. Okay, so that's 3 pounds on there. Now I'm going to do 3 pounds on both sides. One there, one there. That's 6 pounds. All right, 6 pounds is on there. Let's throw another 3 pounds on there in the center. That's 9 pounds. All right, it's holding 9 pounds. Now let's do 12 pounds. Okay. Wow. I can't believe it's actually holding this much weight. 12 pounds. All right. I got 10 pounds here, so that's a big adjustment there. I think what I'm going to do is I'm going to take these off and load 10 pounds on one side and 10 pounds on the other side, and I'm going to walk away as soon as I can. All right. It went from 12 pounds to 20 pounds, an 8-pound increase. It's holding 20 pounds just fine. Now I'm going to slowly add on these 3 pounds, one in the middle, 23 pounds, okay? That's 26 pounds. I heard some crickling and crackling. How about 29 pounds? Oh yeah, I'm starting to hear it crickle and crackle, and it's wobbling on its own. All right. Now, going up to 32 pounds. I'm super surprised, folks. It is holding 32 pounds right now. Wow. I really didn't think it would even hold 32 pounds. Do I dare add more weight? I know I have more weight somewhere. I gotta dig it up. As you can tell, my weights are super clean. They're hidden away. Why don't I go find more weights and add them on here. And I'm just gonna leave these on here, see how long it can hold up 32 pounds. I am really, really surprised in a good way. All right, I'll be right back. All right, guys, and I went and found 2 more 10-pound weights. So I'm gonna take these 3-pounders off. Let's jump it up to 40. Oh, brother. I'm stepping away quick. That's 40 pounds right there. Oh my goodness. Wow. Do I dare increase? I know that it's holding up this much weight without any forces applied, you know, to the left or to the right. It's just a down force. So that's always something to keep in mind. But I said I would break this thing, so 43 and let's go 46. Oh my goodness. I'll be so surprised if I could carry all the weights that I have, which is pretty much 6 more pounds. 49. Wow. And 52. Oh my goodness. All right, guys, that's 52 pounds of weight. And if this just continues to stay as is, I'm one happy camper, because that means I don't have to print out another one. And this is where my test stops, 52 pounds. Wow. Am I the only one that's surprised here? Because who would have thought PETG 3D printed table with only metal screws would hold up 52 pounds? And the next thing you know, it breaks. But no, it's holding up. Strong little table this is. Well, this wraps up the weight test. I'm just going to take the weights off and I'll see you in the 3D printer room. That was a success. All right, guys, well, there you have it. We have the almost fully 3D printed in black PETG Stealth TV tray, and the only things that are not 3D printed are the screws. Those are actual screws, because you saw what happened. This thing held up 52 pounds, and I probably could have added more weight if I had some, but now we know this thing can hold up to 52 pounds without any forces applied from the left, right, front, or back, just downward force. And I am super surprised. It held up to 52 pounds, guys. This thing weighs 4 pounds, 8 ounces. I got to make some adjustments on it, and I can make it available on Make a World if you guys are interested. Today, we're going to finish out building the Stealth TV tray prototype, and I printed out, I actually went into the 3D modeling software, Maya, that I use, and I shortened these dowels, and I printed out new ends for the table for the screw head to fit into, if you can see there. And I'll show you as we put it together, but man, oh man, once again, these prints came out fantastic. But nonetheless, let's get to this, and then once this is done, I can take some pictures, pop it up on Make a World, throw the files up on there, and you guys can mess around with this prototype. And by the way, I do want to just mention that this prototype, the Stealth TV tray, I must say that do not put anything on it, do not use it as a practical table. It's just a model for decorative purposes. You could just put and look at after you build it and appreciate the fact that you were able to put together a prototype fully 3D printed in PETG, and that's pretty much all it's used for. I just wanted to make that abundantly clear, so don't put anything on it, don't use it as a table. And we talked about the potential practical uses in my last video, and that's if it were to be in solid wood. But nonetheless, let's get this built out. All right, guys, so before we continue here, I'm going to show you some of that footage I took yesterday, and once we come back, we'll continue. So I'll see you then. These are the tools you'll be needing for assembling a Stealth TV tray, which is pretty much just a visual model. It's not supposed to be used for practical purposes. It's just for a hobbyist putting together a prototype or trying to see what it feels like to build a prototype, but it is not at all meant to be used for practical purposes. Just kind of like a decorative item. Once you're done, you can kind of put it up somewhere and take a look at it and go, hey, that's pretty cool. And I did print out new versions of these legs to be able to accommodate the washers that I had to take out yesterday, and I'll show you what I did here. First, I'm just going to take this off. All right, you can already see there's a much bigger hole,
with accommodation for a screw head, and it's just the same for this. All right, guys, we're gonna do like we did yesterday and empty out the support material from here. There you go. And we got a little bit of tree support here and here. We just stick the screw in there and kind of get all that stuff loosened up, and it should just come right out. There you have it. That's ready to go. Likewise, we're just going to do the same for this. All right, guys, so welcome back. We're pretty much going to do the same. Just remember the long end of the dowel goes up top, and you know it's the top because, you know, you got the sharp side and then the rounded side. So I'm going to go ahead and stick the sharp side, or the long side rather, here. And just going to grab my hammer and hammer that in. There you go. That's in. And I'm going to do the same for this one. All right, we got that one in too. And putting those bottom parts in should be pretty simple. All right. There you have it. So we have a great leg. I love how easily that one goes in. And put this one in as well. Very nice. Yeah, that's like no seam either on that side, but you get to see a little bit of a seam here. Nonetheless, let's finish putting this thing together. As you know, I did epoxy for this, for these two legs. But, all right guys, so I'm just gonna pop this piece here like that. I'm gonna move this light for right now. All right, there you go. That's a little bit more space. All right, so I'm just gonna stick these on either side like that. And then I am gonna grab one of these screws, and if you haven't seen my last video, then please go check it out. I show you what kind of screws these are and where I get it from. This is just kind of an update video. And then you know, obviously another screw, another washer, and these washers are 3D printed, so it comes with the file. We'll just stick that there, that one on this side, and pop that through. So we got this thread lock over here. We got it from Harbor Freight. And we just want to be careful with all this stuff. Always use protection, such as the gloves, the goggles, P95s. And I'm going to grab a nut here and just put a little bit of this thread lock on that screw, just ever so slightly. If you guys see how little I put, let me see if I can bring the camera. All right guys, so I put just ever so slight dab on there. Like it's so little that I don't even think it will kind of spill off to the other side. I'm going to tighten that up. All right, so I'm just going to go ahead and tighten this up here. Let me first do both sides before I tighten it up, actually, because I'm going to need to tighten up this side anyway. I don't want to flip it twice. Again, I'm just going to put a little bit of that thread lock, just very little. All right, just grab another nut there, and I'm just going to pop that on. Now I'm just going to hold that nut there and rotate this Phillips head until it's semi-tight, but I can still move it. Very cool. Likewise, I'm going to do the same for the other side. All right, that's feeling nice and tight for me. And I'm just going to rotate this so that this hexagonal bar is facing me, so I can attach the tabletop. And again, I'm just going to put the slot facing me, just like that. And because I've updated the backs of these legs, we're going to be able to use the hexagonal washer. Before we weren't going to be able to. So I'm just going to lift up the outside leg, put the screw in the opposite way, so the Phillips head is on this side, and it should sink in. Yep, it's sunk in. I could show you. As you can see there, the Phillips head is sunk in more or less, and it enables it to do what it needs to do. Hopefully that's enough sinking in. We'll find out. And then we're going to put the washer there and just pop it in here. Very cool. Now we're going to go ahead and do the other side. So I'm going to go ahead and grab one of these once again, also the washer. Pop that through, put the washer on there. All right, so that worked. All we're going to have to do now is put a little bit of thread lock on there. And once again, I put very little. Just going to grab a nut here and put it on. And once it's on there, grab my Phillips head screwdriver and just rotate it tight. Ooh, wow, I didn't notice that. It actually sinks in all the way, the Phillips head. You know, when I 3D modeled it, I made it so the whole head sinks in, but when you just put it in by hand, it doesn't. But as you screw it in, the whole Phillips head gets bolted in. As you can see there, it's not sticking out one bit. Very nice. All right, likewise, I'm going to do the same for this side. And last but not least, we got that center bar here. Someone had mentioned doing heat sinks, and that's a great idea. I would like to do that at a certain point, but
For now, we're just using those wood screws. So that's nice and tight in there. All right, just give it one last little turn. So this is ready to go. I do want to wait a little bit before I lift it up and open it. The thread lock says to wait about 2 hours, cures to full strength in 24 hours. And yeah, that's pretty much it. Very happy with that. So here's that Stealth TV tray, and I'm just gonna open it up. It's a little tight as I open it now, but hey, that's all good. And I just rotate this part open. There is the completed Stealth TV tray. This is gonna be up on my Maker World for free download. And you could print and build along for practicing on prototype building. But remember, this isn't meant to be used as an actual table in this form. So this is just kind of a model for you to put together and have fun and look at, kind of like a model car, like a hobbyist would build a model car. But nonetheless, this is complete. It's got the thread lock on there. It can close and open. I really like this thing. It's super cool. But nonetheless, guys, that about wraps it up for today's video. Thank you so much for joining me. Until next time, peace, love, and joy.